Hi, Phil. So this event is brought to you by DataTalks.Club, which is a community, a Slack community of people who love data. And today is our first conference. We decided to try to go from usual meetups that we had every week to something a little bit bigger. And today is our first attempt to do that. Yeah, so today the idea is that we have 4 tracks in this conference, and this track is the first one, which is about use cases of machine learning. So we'll talk today about reinforcement learning, which Phil will present right now. Then we will talk about applications of machine learning and artificial intelligence in the food industry. Then we'll talk about applications of machine learning in for manufacturing, and finally we'll talk about healthcare. And yeah, I think we are ready. And Phil, the floor is yours.
Thank you very much, Alexi. Can I just double check that you can hear me okay?
Yes, yes. Also, I wanted to mention then at any point of time, if you want to ask a question, there is a Slido link in the stream. It's pinned in YouTube chat. So just click on that link and ask any question you want during the talk. And then after the talk, we will go through these questions and answer them. Of course, you can also use the chat in YouTube, but it's better if you use Slido for that. So yeah, Phil, the floor is yours. Please start.
Okay, perfect. Thank you very much. Hi, everyone. My name is Phil Winder. I'm the CEO of Winder Research. We're a data science consultancy based in the UK. And this talk is about the industrial applications of reinforcement learning. It's going to be quite a quick talk, only probably about 30 minutes. It's not very, it's applicable to all audiences. I'm not going to go into too much math or too much detail, but I am going to explain what reinforcement learning is. So don't worry if you haven't come across it before. The main reason why I wrote this presentation in the first place was because I've just written a book on the same topic. So this is Reinforcement Learning by O'Reilly, and the reason why I wanted to create this book in the first place was that I was really inspired by a lot of the research that was coming out of academia and some of the applications that they were able to achieve using reinforcement learning. But I saw and I noticed that many of those advancements hadn't really made it into industry yet. So the goal of this book really is to attempt to gap or span the gap that exists between academia and industry. I've tried to take a lot of research as much as I can, put it into a book that's accessible to engineers that are practicing, engineers within industry. And hopefully you'll enjoy the book and you'll learn a lot more about how reinforcement can be used. So this is a presentation that spins off this book. It concentrates a lot more on the applications of reinforcement learning, and I've got a few videos and demos that I'm going to show to just provide some of those examples. But before we get started, the first question is always, what is reinforcement learning? So I'm just going to attempt to pause the video here. I've forgotten my shortcut keys, not that one. Okay, is it space? It's not space either. Okay, I'm going to have to attempt to use the button instead. So this is a video from a couple of researchers who are attempting to train a chicken to do tasks. Chickens, I have some chickens in my garden. We have some pet chickens that are principally working animals. They produce eggs, but at the moment it's cold, it's winter, and they're not laying any eggs anymore. So they're just lazy freeloaders, eating my food and not doing anything to earn their keep. But give it a couple of months and they'll start laying again, and all will be good. But chickens are actually remarkably intelligent for a bird that is principally considered, to be pretty unintelligent. But actually, you can train them to do quite complex tasks. People think of birds like parrots and things to be really intelligent, and crows and things like that. But actually, chickens have a pretty good amount of intelligence to do some complex tasks as well. So in this particular video, I'm going to try and pause it so that it looks okay on the video stream for you guys. But what the researchers are trying to do is they're trying to train the chicken to tap a particular dot. So every time that this chicken pecks at the pink dot that is on the table there, they're going to reward that chicken with some food, with a tasty treat. And over time, they're adding more and more. They're adding more and more circles to make the task more complex. So the chicken here is having to actively look for a pink circle that exists on the table and compare it against other circles that have similar colors or similar shades. It's interesting that chickens see in full color, unlike some other animals that only see in black and white. Chickens see in full color, so they are able to pick out the differences between the different colors. But you can train the chicken to do this task by providing some positive reinforcement. So every time it does something right, it will get some food. Every time it does something wrong, and I think I've just paused it in the right place, because the researcher on the left there, she moved the pink dot away, and when the chicken turned around, it expected the pink dot to be in the same place where it was before. So it's instinctively started to dip down and try and get to the pink dot, only to realize that actually it's pecked in the wrong place. And in that particular instance, it will not be rewarded. It will not get a positive reward from that action. And instead, it needs to try again. Wrong button again. Sorry about this. So that food that is being provided there is the act of reinforcing a behavior that we want the chicken to learn. And this, in essence, is what reinforcement learning is. We're attempting to train an agent, which is in this case a chicken, to perform behaviors or enact strategies, and we teach the agent to do that by providing a reinforcing signal. It can be positive or it can be negative. Both tend to work reasonably well. Okay, so that's all well and good. So how far can we take this? How smart are birds in general? Well, a long time ago, this is some research from Skinner, I believe, and he trained. So this was, just to give some context, I definitely clicked the pause button there. Definitely clicked the pause button. Damn you for clicking. There we go. This was during the time when pigeons were being used for all sorts of tasks. Carrier pigeons were still being regularly used for communication, and pigeons were being trained to spot submarines during wartime and things like that. So this was kind of part of the same era of research, and he found that he could train pigeons to also read. Again, the way in which you would do this is you present some input, some stimulus to the bird. In this sense, it's a sign here at the top right that says peck. And if and when the bird actually performs that action, then a little treat is delivered through the slot below. And over time, he managed to build up quite a repertoire. We've got peck there, we've got turn, telling the pigeon to turn around, gets a little treat, positive reinforcement, turn again. Okay, so these are pretty advanced behaviors. So how far can we take this? I found this clip on YouTube and it's amazing. This is a guy that has trained his chicken to do all sorts of feats. I love his t-shirt. It says, my chicken is more intelligent than your dog. And he's, in this time of nationalism, he's trained his chicken to be a nationalist, and he's trained his chicken to recognize the Spanish flag. So as you can see, he's ignoring the French flag there, ignoring the Swiss flag, because, the Spanish flag is definitely the flag that's most interesting to that chicken. And we've also got this extreme example of patriotism here. If and when chickens do take over the world, they're going to be able to raise their own chicken flag. And all of these behaviors were all trained through reinforcement. Okay, so this is the general gist. We're trying to train the agent, which is a chicken. Oh, and she loves it. Trying to train the agent to do complex tasks, and all the chicken lovers love it there, to perform complex tasks through reinforcement. So let's step back a little bit, and how can we apply this to industry, and why is it of interest to engineers that work in industry? I think we need to step back and establish where reinforcement learning sits as a tool. Like when would we use it? Because this is just another set of tools that we can use to solve problems. So in terms of a day-to-day business, there's kind of three level, or very, very simplistically, there's three levels of business that happens on a day-to-day basis. Businesses enact processes, things like, printing forms, sending mail, informing customers, speaking to people, providing their product, things like that. Also, businesses make decisions. So these tend to happen less often than processes underneath, but they tend to be more important. So decisions like, are we going to give a loan to this person, or what product should we build next, or so on and so on. And finally, at the top level, we've got strategy. Strategic businesses attempt to map out long-term goals for the business, ultimately to build a successful business. Now, strategic decisions happen rarely at all, but the strategic decisions are really important because they inform and control and direct the decisions that are going on at the lower level, and finally the processes at the bottom level. Now, the value of each of these actions, because of the nature of what they do within a business, are quite different. Processes like how to connect your laptop to the works printer, it's a process and it's important, but it's not very valuable to the business. Decisions are quite valuable because if you are about to give someone a mortgage, then you could potentially lose a lot of money if they don't pay that money back, or you could make some money similarly. Finally, strategic actions tend to be the most valuable because they're the ones that help define what success is. They're the things that can really make a business, and therefore they are the most valuable. Get them wrong and your business fails. It's the ultimate. It's the ultimate in the value chain in a business. And over time, we've developed tools and techniques and technologies to automate these parts of the business. So we use software to encode business processes. We've been doing that for a long time, and there is value in that. And obviously, there's a big industry supporting that to build and write software to encode and define these processes. I see ML kind of at the level where you are attempting to automate decisions. So we can train a model to make a decision as to whether that person would be accepted on that loan or not, based upon previous data, things like that. So that automates the decision. Now, RL, that is the thing that sits on the top. That is the thing that defines the strategy. We can use RL to help optimize strategies. So basically longer term thinking, things that take sequential decisions over time, that's where RL fits in the stack. So it's my opinion that RL is very valuable, but you've also got to bear in mind that actually these strategic decisions don't happen that often. So probably the market is a bit smaller, in the same way that, the ML market is quite big, but the software market is bigger because there's just more users of software than there are of ML. And similarly, there are more users of ML than there are of RL. But still, it represents a tool that you can use, something that you need in your toolbox to be able to solve those specific strategic long-term problems. Sorry. Okay, so what do I need in order to do RL? I've already mentioned some of these terms a little bit already when I was showing you the videos. The first one is the agent, this thing at the bottom. The agent is the thing that actually builds the internal model to solve a task. And in the previous video, it was the chicken or the bird. If you imagine trying to teach your children to ride a bike, then the child would be the agent, and the child is cycling within an environment. The environment here is the world. It's the sensation of wind on the face. It's the view of the trees and the grass on the floor. It's the it's the feeling. It's the feeling of acceleration and enjoyment and pain when they fall off. Okay, so it's everything, all of the representation of the outside world, everything that is external to the agent is the environment in which the agent acts within. Okay, the agent is able to select from a certain number of actions. These actions might be, in the cycling case, might be to turn the handlebars to go left or right, might be to pedal forwards and apply some power to the pedals. It might be an action to shout, hey, Dad, look at me. And all of those affect the environment in some way. They mutate the environment. So if I turn around 180 degrees by turning the steering wheel, then the environment's going to change. I'm going to have a different view. I'm going to be able to see something different. I might be feeling different things. I might be hearing different things. So the actions provided by the agent mutate the environment. Then the environment also needs to feed that information back to the agent in some way. So that's called the state or the observation of the state. And this could be like a visual data, like a camera or something from your eyes or your ears. In the chicken example, when the researchers were moving the dots around to train the chicken, the state could be potentially the positions of those dots or a picture of those dots. That would be a representation of the state of the environment. And obviously, when you're going around in this loop, you're enacting, you are performing actions to mutate the environment. So that actually changes the state. And then again, the agent will then look at that state and suggest another action. And this goes round and round and round and round and round and round. There's one final thing, though, that's really important, and that's the reward. This is the thing that tells the agent that you've done something right or you've done something wrong and you need to change your model. If you've done something right, then it's reinforcing that model. It's saying that was great, keep doing it. In the cycling example, the reward could be, the pleasure from, cycling or of the freedom that you get from cycling, or it could be the pain from falling off your bike. And remarkably, but both of my kids now, my youngest is 4. I think they both learned at about 4. It's about 4 or 5, but at the age of 4 or 5, they were fully capable of pretty much learning how to ride a bike entirely by themselves. Like, you give them support and a little push and stuff, but at some point it just kind of clicks. They get the right model in their head. They know exactly what happens with the bike, and away they go. Okay, so it's a remarkably simple framework, I guess. It's a remarkably simple framework, but it can result in really complex behavior. I thought there was a video there, but there's one video that, is it later on? Yeah, it's not. Okay, there was one video that I really like where there was a chap who took a bike and he reversed the steering on his bike. And so if you, so typically if you turn the handlebars, like, pull with your left hand, it turns the wheel to the left. Basically, put a cog on there so that when you pulled with the left hand, the wheel actually went right. And it was a really good experiment because it's remarkably difficult to adapt to such a simple change. Like, it's just such a simple change, but the models that you've produced when you were 4 or 5 year old to ride a bike are so deeply embedded within your head that it can be really hard to bring yourself back out and basically say, I have to relearn how to ride a bike. And it is possible, and he did do it, but it just took a certain period of time. But conversely, when he gave that to his son was able to get it in 20 minutes or something, and it was away. So anyway, a bit of an aside there. And so the purpose of this talk now, I hope you gained something from that. Obviously, there's a lot more detail about this. This is called the Markov decision process, and MDP is the mathematical name for it. There's a lot more about this in the book. So if you're interested in the details, then I refer you to the book. But as part of writing this book, I was really interested in the applications. I really wanted to collect and talk about some of the use cases that people have tried, that people have succeeded in, and less often failed in, which is a problem with academic research and research in general. You don't hear about the failures. But it was remarkable, and what I found, the spectrum of ideas and things that people have tried was surprising. And so I started to collate all of this information. I started to categorize it and keep it, and I've put it on the website for everybody else to have a look through. So if you're interested in finding applications in your specific domain, then I suggest you go to rlbook.com/applications. I'll just go to the rlbook.com website and you'll find the link at the top, and you'll be presented with a big selection of use cases for your particular domain. So I'm going to talk about a few of those now. I think I've got 3 different sort of distinct industries that I'd like to talk about. The first one is manufacturing, and in manufacturing, there's lots of sub-use cases that are also interesting. So for example, like supply chain management, inventory control, these are pretty big applications within manufacturing. But one of the coolest applications and the most visual is robotics. Okay, so I'm going to start off with a couple of examples, and yeah, you make of it what you will. So this is a really interesting video of some research that people did to take an off-the-shelf robot, which I can't remember who makes this robot now, but it's a robot that you can buy off the shelf. And that robot comes with a predefined set of moves that it can perform to do certain tasks. So for example, it comes with a pre-built set of algorithms to walk forward, to turn left, to turn right, walk backward, things like that. What these researchers were interested in doing was to see if they could look at a real life animal with a similar that has a similar what am I trying to say? Basically, they wanted to find out if they could look at a dog and use motion capture to capture the movements of a dog, and then try and train the robot to mimic the actions of the dog. And so over time, they managed to train all sorts of more complex behaviors, like a backwards trot, for example, or side steps. And all of these behaviors were not available are not available off the shelf, okay? Because some of these behaviors are really quite complex, and they're very hard to encode. So in fact, you need to learn these behaviors. We've got some sort of complex turns there. This is one of the coolest ones. So this is like a 90-degree like hop jump, and this is incredibly difficult to program because of the complexity of the movements involved. I'm going to try and pause it just so you can see some of the joints and how they move. So you can see here that there's the joints are kind of moving in opposition, and the way in which they're bending and putting strain on the motors is something that would be very, very difficult to hand code. I mean, I'd just have a go trying to hand code some robotic movements. It's actually remarkably difficult, but you can use RL to train an algorithm to produce these behaviors based upon some motion capture footage of a real animal. Okay, so then they go into the details of how they trained it. All right, but that's cool. You can check out that example if you're interested. Next one. This might seem a slightly more boring example, but actually this is really fascinating. I'll explain why in a minute. So what we've got here is we've got a couple of sort of articulated arms. You see the servo motors here. They're all connected together with a little sort of manipulator thing on the end. And the goal of this challenge is to rotate that imaginary valve to a predefined position. Sounds simple enough. And it sounds like it doesn't really have a real life application, but it does. Like I've worked with the oil and gas industry quite a lot, and they have a lot of applications where they simply need to turn valves to an off position or an on position, and they've got no way of doing that other than doing it by hand. So they actually have robots that can be driven up to these things and attempt to spin them. So I mean, it is a real life use case. But the problem is these valves are all different size and shapes and looks and feels. Some have got handles, some are like round, like steering wheels, and some are just bars, etc., etc. So again, it's ridiculously hard to try and program a robot to do this from hard-coded rules. So what you can do is learn how to do it with reinforcement learning. The particularly cool thing about this application is that the only thing that is being used to train this robot is this video camera. This is the only thing that these arms are actually using as their state, using as their input. And over time, it is learning to position this valve in a very particular way, purely from the video camera. So actually, the coolest thing about this research is not necessarily the application. It's the fact that you can train a very complicated, articulated robot with just a video camera. So that opens up a whole range of applications, and one in which we're going to, I'll leave that for a second. I'll show this one first. And one which leads me to this. So this is actually a real life pick and place robot in Berlin. And earlier this year, a company called, I've put my video over the top of the source there. The Covariant AI is the company that did this. And yeah, they've used reinforcement learning to train a robot to pick up any object. You see, let me try and see if I can pause it. There we go. So there's just some white boxes. There's some orange boxes, small boxes, thin boxes. And we've got anything more interesting than that. I saw a roll of tape, oh, look at that. So that's like a plastic bag with some sort of plastic shapes inside. All of these things are completely different shapes. And again, it would be very hard to manually hard code a way of telling a robot to pick up an individual item with a simple manipulator or even a complex manipulator. But using reinforcement learning, it is possible. And again, you can use, for example, a video camera as the input to this. I believe it's got several cameras on this robot. And you can use that information to train the robot to do certain tasks. Okay, so in the past, one of the main problems with reinforcement learning was getting the information to the agent that is representative of the problem at hand, and then processing it in an efficient way. But the confluence of the advancement of neural network based models and computer vision and things, paired with the advancements in reinforcement learning and the techniques and the models, put these two things together, then we can get some quite complex applications. So let me go back, because this one's really fun. One thing that's really, there's a whole range of robotic examples out there, and they're all really cool. But I like this one because this is demonstrating something that's seen in other parts of ML, and that's adversarial training and adversarial attempts to break models. So what's happening here, this is just a simulation, but the simulation has included a model, quite a complex model of a human being. So there's lots of, imagine this to be a humanoid robot, lots of joints, lots of movements, and it's been trained to kick a ball. And so it can kick a ball, try and score a goal. The blue robot, sorry, what happens if I just click? I could just click in the middle. So the blue robot has been trained to score a goal. So it's going to try and move and wiggle across and try and score in the goal. So when it does score a goal, it gets positively reinforced. When it doesn't score a goal, it gets a negative reward. You see the red robot in the goal there, that's trained to try and save the goal. So again, it's trying to, it gets rewarded when the ball doesn't go in the net, and penalized when it does. But what they found is that after this training, if you then, you can then adversarially attack one of the models, in this case, the RL agent that is blue robot here, you can adversarially attack that model by presenting it with data and presenting it with information that it has not seen before. So in this case, it's learned that if it just falls on the floor and just flails about a little bit, the blue robot doesn't really know what to do because it's never seen this before. So in fact, it just looks a bit drunk now, stumbles off to the right, and it can't even kick the ball. It just falls over because it's never observed this before. So it's never learned to deal with this scenario, and it just about managed to cope with it there, but it's certainly more drunk than it was before. So again, this is all based upon ML. A lot of these models are neural network based, so a lot of the same caveats apply. I'll just leave it there. Okay, so let's move on to a different industry. So the tech industry is a big user, well, it's not a big user yet, but it certainly could be a big user in the future. One of the coolest examples that I came across was the automation of common office-based technology tasks. And in this case, the researchers created a framework that allowed you to present an agent with a HTML styled application. And in this case, it was a simple email application. And the researchers wanted to try and train an agent to be able to perform relatively complex tasks, things like, taking some text or a command and saying, please forward Kyle's email to Alice. And throughout a whole range of these scenarios, the agent was trained to perform these commands. And this is an example of forwarding one of the emails. And you can see that there's a series of steps that the agent would need to go through. Each of the boxes at the top represent the state. So this state is represented by HTML and just text. The actions the actions presented to the agent were things like CSS selectors. So it's like select a certain HTML element, or copy a certain piece of text, things like that. And as you perform these actions, you get into different states. So in order to forward the email from Bob, the agent first needs to learn to click on the email from Bob, and then it needs to learn to click on the forward button at the bottom, and then it needs to learn to type the word Alice in the to box, and finally hit the send button at the top right. Okay, so that's like a full end-to-end chain. And this may not render in your video, I hope it does. But basically, this is a visualization of the agent learning in real time. And this is kind of at the end of the process where it's got a pretty good model, and it is able to do really quite complex things like, click an email and forward it to a particular person, or delete a certain email, or reply to someone with some text there. In the yellow box, you can see the command that is being presented to the agent, and they're pretty complex. Forward all mail from Patricia to Ginger. Tell Anita some Latin I'm not going to pronounce. Freddie needs an email, blah, blah, blah. Find Kirby's email and say something. Highlight, so on and so on. This is really complex, but this has potential to provide a level of automation in sort of traditional office-based technical tasks that I don't think has been seen before. And even though this is like simplified HTML, obviously, I feel like that there's just a use case that is just waiting to be discovered to use this technology on. And when they do, I'm sure it's going to be really successful, and it's going to be really popular. So get your thinking caps on, everybody, and then tell me. Okay, moving on to transport. This is the final one now, so not long to go. This is a quick sort of wrap-up video, really, showing lots of different applications. One of the main applications that has been tackled in transport is traffic management. It's specifically, given a busy road, how can we manage it in such a way to optimize for efficient flow and max speed and no delays and things like that. So these are just some videos of examples of various frameworks using reinforcement learning to train how to manage these things. And I'm going to just pause it in a second. Here we go. So what we've got here is a really complex simulation of merging roads, and this is really cool. This is a really cool application. Basically, what the researchers did was they assumed, and this isn't, well, I'll get into the assumptions in a minute. They assumed that you had a motorway or a highway that you are able to tell drivers to set their cars at a certain speed. All right, so you can imagine that maybe these are autonomous vehicles, and there's a direct command. You must travel at 30 miles an hour or whatever. Or it could be like a human. There could be signs above the road that enforce speed limits for individual cars. It's not infeasible, but it's still a bit of a leap there, a bit of an assumption. But the cool thing is that you can use reinforcement learning to learn over time how to tell these vehicles to travel at a very a specific speed, so that later on down the road, a merging lane can simply just pull in. It can pull in, and it can be guaranteed that there's no car in. There's no crashes, and the merge is perfect. Nobody needs to slow down. Nobody needs to speed up. nobody needs to check. You just merge. Okay. So I feel like that this particular example is like, it's on the cusp of being possible, like not quite there yet, just because of the underlying infrastructure that would be required to do this. But I feel like we're not a million miles away. And, you know, if we were to do something like this, then, you know, that would be the end of traffic jams, effectively. No more traffic jams, because you can, you know, a long way back, you can tell vehicles to travel at a very specific speed so that they never have to stop. And I personally can't wait for that to happen because I hate sitting in traffic. It's the worst thing ever. Okay, I'm not sure what time it is, but I think I've probably used up all my time. I'm going to just stop there, and I'd just like to forward you to the book. So the book goes into a lot more detail. It talks a lot more about the algorithms and how you can actually use some of these algorithms. There's still quite a few applications in there as well. If you are actively working on a reinforcement learning project in your company right now, then I really, really would love to speak to you. I want to, you know, hear about what you're doing and whether you need help doing that. And if you do need help, then yeah, my consultancy, winderresearch.com, is here to help. And yeah, that's it. I'll answer any questions after we finished. Thanks a lot.
Thanks. I shared the link to the book site. It's in the chat in YouTube, and also you can find Phil in DataTalks.Club Slack. Yeah, so we do have a couple of questions.
Yeah.
Michael is asking, could you elaborate on the reasons to see reinforcement learning chiefly at the strategic level? Many use cases, for example, in robotics, don't seem strategic to me.
So I was just getting my my speaker volume back up again. Can you just repeat the question again? Sorry.
Yes, sure. So the essence of the question is the examples that you showed do not always seem strategic. Yet at the beginning you showed this pyramid, and the reinforcement learning was at the top, right?
Yeah.
So and the question is, why do you think it is strategic? Because most of these cases, they don't seem strategic.
Yeah, okay. So it's basically the definition of what is a decision and how many decisions need to be made over time. So a strategy is basically a set of rules that allow you to make multiple decisions over a long period of time. That's the definition of a strategy. In reinforcement learning, the technical term is policy, but I actually find the word policy a little bit, you know, hard to understand. So I tend to use the word strategy because it kind of maps to what we think as of the word strategy. Whereas, like, conversely, a decision, an ML algorithm will make a single decision at a single point in time. So, for example, imagine you have you're an e-commerce company and you're trying to optimize your advertising or your recommendations so that people buy more stuff. A current and typical ML setup would be to optimize for the highest chance of that person buying the product right at that time. Basically, you want them to click the buy button right now, even though in the long run, it might not be the best decision to actually sell them that product. Actually, a slightly better example would be the recommendation of like news stories or articles or something. If you go for the most clickbaity news article, yes, you'll probably get the click there and then. But actually, the long term retention of that user is probably going to be affected because they're going to say like, well, I'm not going to use this service anymore because they keep recommending these real clickbaity, horrible articles, and I'm not going to do it. So when I say strategy, what I mean is a strategy is something where you're optimizing for decisions over a period of time, over multiple decisions. So for robotics, for example, it doesn't look strategic in the business sense, but it's very strategic because, you know, a decision to move from point A to point B is part of a longer strategy to make a cup of coffee or to pick and place something from one box to another. You know, you can't do that with ML. Does that make sense?
Yeah, it does. Thank you.
Great.
Then we have a question. So thanks for the great talk. Yeah, thank you indeed. How can RL agents be trained well for strategic decisions as they occur so rarely?
Yeah, that's it. That is actually a really good question. That's one of the trickiest problems in RL, and you'll find that you need to rely on simulations a lot more. So during the development cycle, you're trying to figure out like what's the best way in solving this thing. You're iterating over algorithms, you're iterating over ways of feature engineering and things like that. And the best way to do that is through a simulation. So there's a lot of work gone into some very sophisticated simulators for certain domains. Like the most obvious one is the 3D world simulations and renderers, you know, the unities of the world. They've put a lot of effort into making it like physically you know, to put the physics in the simulation so that when you take it out of the simulation, it's as representative as possible. However, that's not the only solution. That just helps you with the development. The next solution is that there's a whole branch and there's a whole box of new techniques that allow you to take historical data and use that to train a reinforcement learning model. It's called offline learning. So although they may not happen frequently, they probably have occurred many times in the past. So you can leverage that information to train your agent to basically not start from zero. You know, you can start from a much better position. So yeah, basically the combination of better simulation and also offline logs, I think partially solves the cold start kind of problem.
This is how AlphaGo was trained, right? So first they looked at the logs at previous games.
Yeah, right? That's a little bit different though, because the environment was so simple. It's a game, you know, it's got very fixed rules and it's got a very low dimensional space to operate in. So they can physically simulate every single possible move that would ever happen in a game. So in that case, you effectively just need to run the simulation enough times, and then eventually you've kind of seen every possible thing that could happen with it. I know there's lots of permutations and stuff, but you can physically do it. Like now extrapolate that up to like a self-driving car. Like you can't possibly see every single situation that a self-driving car would ever see in a simulation because life is just too complex. So in that case, yes, you can learn from the simulation, but you really do have to actually get out in the world and actually experience things to generate the data to be able to train a better model. And that's exactly what all the big self-driving car companies are doing right now, where they're just collecting huge amounts of data in order to try and, you know, cover as many cases as they possibly can.
Yeah, I think these companies, self-driving companies, they have like even replicas of real cities, right? So that the car can drive there and learn. Right?
Yeah, exactly. Yeah, I know. Yeah, I mean, it's crazy the extent they have to go to, but even then, that's still not enough. You know, you still need to go to India and attempt to drive a car in India, then you're definitely going to see. Figure out. I think it would just get stuck. It wouldn't move because there's just so much chaos going on around it.
Okay, then we have a question from Razona. Can you sketch a list like here are the things you should minimally have in your use case for reinforcement learning to be applicable? Like what are the things?
Yeah. Okay. Good question. Let me try and. So the real thing that is, I think, the most difficult thing to get your head around when you're doing reinforcement learning is that you have to accept that the algorithm and the agent, the algorithm inside the agent, actually has the capability and the mandate to try whatever action it wants to try. You can't, I mean, so there's a lot of work on safe RL, by the way, the big caveat there. You can constrain and control and make RL safe, but somehow like letting go of, we're so used to doing supervised machine learning that, you know, it's under our control. It's quite a leap then to go to reinforcement learning to say that actually the agent needs to do its own exploration to figure out what the best strategies are, and there may not be what you expect. There may be something completely different. So I think that's the first thing, is you've got to kind of get your head around that. But then after that, it's just basically solving the MDP. What's the agent, you know, what's actually doing, what is generating the actions, what actions can it generate, what environment is it working in, what is the state and the observation that comes back from the environment, and then finally, how do you encode and decide upon the reward that comes back from the environment. And actually, out of all of that work, it tends to be the observation of the state. There's a lot of feature engineering that goes into that step, and also the definition of the reward. That can really trip you up, because you can think that you're rewarding the best behaviors, but in fact, it promotes bad behaviors. So again, you need to go through a lot of it. Well, I guess you call it reward engineering, in order to figure out what the best reward is. Slightly
definitely not an easy thing to do, right?
No, it's not simple, but it's doable.
Okay. Then another question from Rezona. For both examples just given in CRM, it's hard to track these people. They visit website once and then 3 months later they sign up. How would reinforcement learning help?
Yeah, I mean, that's a perpetual problem. Like marketing, they want information about, as much information about the person that's visiting their website as they can, but they're no longer allowed to capture that information from from any other means than the information that's provided by the person. So I think the problem lies elsewhere. That's not a reinforcement learning problem. That's a data collection problem. In terms of reinforcement learning, you know, the goal here isn't to convert someone from well, I guess it is. Reinforcement learning in that case would help, I think, in the traditional testing of different parts of the website or the workflow in order to optimize to, you know, improve customer sales. So the classic technology at the moment is kind of A/B testing. Now that's the simplest version. Then there's multi-arm bandits, which is like a level above that. And that is actually a simple form of reinforcement learning, by the way. Multi-arm bandits are kind of considered to be part of the reinforcement learning bandwagon. And then you can keep going up with more sophisticated algorithms that are able to learn more complex and more complex behaviors and deal with more complex actions and states. So I think that's kind of the thing that jumps off the top of my head. You can imagine a situation where, yes, you've only seen the customer once, and yes, they come back 3 months later to purchase something. But in the meantime, you can tinker with the whole website. You can get an RL algorithm to generate new text, to change different colors, you imagine every single person that visits that website might be viewing a different version of that website. You know, things have moved around and they're reading different things. And even though there's only 2 touch points there, with enough customers and enough data effectively, you should be able to tell like what, or the model, the agent rather, should be able to tell which works the best for your product and your company.
And multi-arm bandits are probably the most widely used method of reinforcement learning.
Exactly, yeah.
So the next question we have is strategic sequential decisions cannot be simulated in some cases, like real world strategic decisions that impair huge risks.
Yeah.
Can it still be achieved?
Yeah. It depends. You know, it depends on how not possible it is. Like, I've worked in several industries where it is very expensive to perform experiments, and so, you know, you can do them. You just need to orchestrate them in such a way to make them as cost effective and as short as possible. If it's a safety thing, then again, you can generally figure out ways of testing up to the point where it becomes unsafe. And there's the whole branch of RL called safe RL, safety driven RL, which attempts to provide ways and means of making RL algorithms safe. So if that's your concern, simulations are a massive help here. Simulations can be created that are so sophisticated that they're almost like real life. So simulations can really help. But yeah, you're right. Sometimes there's just certain things that can't be tested in real life. And, you know, similarly, there's in ML, there is maybe certain applications where it's just impossible to get the data. And in those cases, there's probably just lower hanging fruit. There's probably simpler problems that you can tackle that can be solved. So I would probably just consider changing the problem definition.
Okay, thank you. What is, in your opinion, the current bottlenecks of expanding applications of reinforcement learning to more tasks and fields, like development of algorithms, hardware, and etc.?
Yeah, good question. So I think that the hardware is probably good enough for many use cases. I think, to be honest, I think there's maybe just a lack of awareness at the moment, and that's exactly why I wrote the book, to try and increase awareness in this area. I think that many engineers have just not heard of it before. It's still considered a very academic subject. So give it a few more years, and I think that once people start hearing the word, they'll potentially start using it more. I think inherently there's a narrowing of the market, so like in the same way that the ML market is not as big as the software. Everyone's heard of software engineering, even my mum. Most people these days have heard of ML and AI. Not necessarily my mum, but hardly anyone's heard of RL, and it's because the application of RL is probably a bit smaller than ML in general. Therefore, it's applicable to a smaller number of applications. But with that said, I do think that we're not at that point yet. There's definitely a gap between what is possible and what we're doing at the moment. Bottlenecks. So I think it just comes down to understanding, knowledge, the application of these things. But then on a technical level, it's probably, I think, simulation. In fact, here's one thing. I think that the current problem is that it is technically possible now, but it's quite difficult to learn models. I think that's the future of RL, actually, is learning models, learning simulations. At the moment, simulations are still very hand-coded. They're created by humans according to physical rules. But I think that there's a potential for us to be able to learn a simulation or learn a model effectively from log data and then use that as our simulation. And that already exists to a certain extent. It's using like variational autoencoders to generate and then we can apply random noise to the output of that to generate new scenarios and use that as a simulator. So yeah, I think we're getting there. But once we get an ability and a framework and some code to be able to basically create and learn a simulation for any data, I think that would be really powerful, because then you can really truly do your development offline and be not guaranteed, but you could be much more certain that you've got a really good model before you actually start trying it in real life.
So it's like using reinforcement learning for training reinforcement.
Yeah, it's a bit meta. Yeah, well, in fact, there is meta.
Right.
It's learning how to learn optimally. So it is a subject. It is an academic field. Yeah,
but can also be like these, adversarial networks. Crazy people who jump in front of cars or things like that.
Exactly.
Simulation.
That's part of it. Yeah.
So we still have 2 more questions. Can you elaborate on feasibility of reinforcement learning for strategic business decisions, like pricing strategy, launching different product features, which customers to contact, and so on?
Did you say visibility? Sorry. What was the start?
Feasibility, like
feasibility.
Yeah.
Okay. Yeah. No, that makes sense. Yeah. I think all of those are applicable. The answer is yes. Yeah, very feasible. Anything that you can imagine performing multiple experiments to arrive at an optimal value, that is a great application for RL. Like, I think most of the research and most of the work so far has been done in not pricing, but the other end of the spectrum, the bidding. There's been a lot of research in bidding. So attempting to, control and constrain like advertising budgets, for example, to be able to bid in an optimal way. So there's been a lot of research into that. But I can easily imagine that if you had a large volume of sales, so you're coming from the other direction, if you're setting the price, you could also use RL to set the optimal price, which will probably change over time. And in fact, there's many companies that attempt to do this for, like, Amazon prices and OLX prices and things like that. But I think RL has the capability of making that a bit more sophisticated. Like, if I go and look on, there's a famous, I don't know if it's around the world actually, but in the UK there's a website called Camel Camel Camel, which is probably the best name for a website ever. But it tracks Amazon prices, and so you can see the history of the best price in Amazon, and it's really jagged. It's like some of the algorithms that are used to set these prices are really, they're not there's no finesse to them. It's basically fix the price there and fix the price. There's got to be some better algorithm, like an RL based one, that is able to set prices a bit more intelligently.
Okay, so we need to wrap up. We have one more question, but I think they are pretty short. So first question, you probably get it regularly. Are you hiring? And if yes, what kind of people you look for?
Yeah, send me an email. Yeah, I mean, we do a lot of work, consultancy, generally more in the ML space and the RL space at the moment. But I'm hoping that we will. I'm hoping that the future is quite bright for RL. So yeah, just get in touch over email.
Yes, and the other email is related. Hey Phil, are you available? And what's the best place to contact you for an additional 30 minutes talk?
Yeah, definitely, 100%. And just contact me, winderresearch.com, Phil at winderresearch.com. Details on the slide.
Yes, and I did share the link to the book, and probably there is information how to contact you.
Yes, exactly. Yeah.
Okay.
Perfect.
Thanks a lot.
Okay.
Yeah, we still need to take a small break.
Okay.
Thanks, Phil. Thanks everyone for watching and asking questions. And now, yeah, I need to. We have new speaker. Okay. Yeah, Phil, you're free to go. Thanks a lot.
Okay. Thank you very much. Thanks, everyone. Have a good day.
Yes, thanks. Goodbye.
Hey, hi. How you been, Alexei?
Yes, how are you?
Yes, all good here.
So let's have a short break, 3-4 minutes, and yeah,
sure.
Yeah, because the talk took a bit longer, but probably yours will also take more than 45 minutes.
Right, yeah, I'm pretty sure on that.
Okay.
So you're based out of Berlin, right?
Yes, I need to take a small break, so I'll be back soon.
Okay, sure.
Okay, I'm back, and I must apologize. I forgot to announce the winners of Phil's book. Sorry for hijacking your talk. It's just, yeah, I should have done this when Phil finished. So let me quickly share my screen. So these are the winners. So we had a raffle on Twitter, and those people who retweeted, they will get the book. So these are the handles. So we will contact you after the conference today, and we will need your emails, and we will give your emails to O'Reilly Marketing, and they will contact you and give you the book. So thanks a lot for taking part. And it's pity that Phil left and doesn't see this. But yeah, I will tell him that that his book will find the winners. And if you are ready, I think we can start.
Sure. Let me share my screen. Okay, let me know once you guys are able to see it.
Yes.
Okay, you can see a presentation saying how to use AI for CPG food innovation, right?
Yes, exactly.
Great, awesome. Right, so I guess, yeah, we can get started. Essentially, the idea of today's talk is to give the audience a flavor of how AI is being transforming the food industry and specifically the CPG, which is the consumer packaged goods. Companies like Coca-Cola, Pepsi, etc., who essentially manufacture millions of products and how exactly AI can be used for transforming that. So before I get into all that, let's talk a bit about AI, machine learning, and deep learning, right? Obviously, these topics have been picking up in the recent 5 years, I would say, at a very rapid pace. There has been a lot of work which is coming from the academic space. In terms of the company side, also, you can see a lot of applications of AI emerging, a lot of startups that are coming up. And no wonder AI is becoming like one of the major popular topics. And the another interesting comparison here is with TikTok. So you can see TikTok started essentially in this 2017, and then it started rising up, but AI still remains on top of that. And how exactly we are using the AI in everyday life? Well, there are multiple applications, right? When you are opening up an email, there's a spam filtering which happens. It's a classification algorithm. You have the conversational AI, which is picking up the voice to text feature is happening on the voice side. Then you have the transactions when you're using any card for that matter. I used to work previously at Visa, and that's where we would identify the fraud and the other anomaly transactions being done on your using your card or using your Apple Pay or whatever. Then on the social networking side, you have the different image analytics, the computer vision algorithms that suggest you, for example, who are the friends that you should be tagging in the images. And finally, in the and the ride sharing apps. And these are just some of the things which you use on an everyday basis. The idea of this slide is basically to help you understand how exactly your life is being surrounded by AI, even though you might not know about it or you might be using it without understanding it. And that's why AI as a topic becomes really, really important if you have to understand the implications or the applications of it. And the difference among AI, ML, and DL, again, it's very rudimentary, but at the same time, it is something that should be clear in everyone's head. Artificial intelligence, as we know, it's more about artificially creating a intelligence or mimicking the human intelligence. It can be a simple if-then rule, which is also a kind of artificial intelligence, or it can be decision tree or deep learning or machine learning. While machine learning, on the other hand, is a subset of the artificial intelligence that essentially is more about the statistical techniques that you use, where you feed in a certain amount of data and then it becomes better at predicting those tasks or giving the certain output. The deep learning, on the other hand, is now the niche which is coming up. I'll talk about the reason of why deep learning has become more and more popular, what are the reasons behind it. And again, in this particular case, using the artificial neural network, the machine itself is able to understand and outperform itself. A classic example being Google DeepMind beating a Go champion. Go is a very popular game. It's similar to chess, but it's more complex in terms of the different possibilities or the different moves that are there at one particular point of time. And that's where deep learning is now becoming hugely popular in the AI space. Okay, I mean, this is again additional comparison slide where you can see that, okay, ML, the classic ML is the regression and all that, which starts from where you're trying to predict the weight or the height part and you're plotting your regression lines on top of it. While the deep learning is more at a level where you are trying to reconstruct or deconstruct the features out of a particular data set, which can be quite complex. For example, given a face input, there are multiple layers which are analyzing the low level features, certain mid level, which you can see here, and then high level features. Okay, I think that was just a short intro about the AI ML, which I'm sure the audience, you guys are already aware about, but just as a refresher, I wanted to introduce. Let's deep dive now and jump into the CPG space, which is the consumer packaged goods. It has the different companies, you would have either had like multiple products of these companies, which is Nestle, Kellogg's, PepsiCo, Coca-Cola, etc. They have numerous brands under them, often varying from geography to geography. And these are some of the major ones which essentially occupy the entire market. And the biggest problem in the CPG industry currently is that the 90% of the CPG products fail in the first year itself. What this translates to is that next time you visit a shopping complex, or if you visit a supermarket, 9 out of every 10 products in, or let's say any one product that you pick will have a only like 10% chance of the success, while it is highly likely that okay, out of the 10 items which are there on a particular shelf, 9 of them are failing in the first year itself, and you will not see them again, right? And this is a very high failure rate if you think about it, because I mean, this industry is one of the most basic industries in terms of the food. This is one of those industries that was able to withstand the COVID, but in spite of that, a lot of the food products or the CPG products, they continue to fail. Now, why does that happen? And okay, I'll get into the why part, but let's talk about the current process of how exactly a product is actually developed, right? There are multiple stages to it. The first starts with the conceptualization, where uh, the company itself tries to employ either an agency or an in-house service to come up with what kind of concept that they should be launching in the market. So this involves a little bit of market research. It also involves leveraging the agency who can do certain surveys and identify what are the different things that are popular in the particular market and the category. Then once they have identified on the concept, then comes the prototyping. Prototyping is essentially you are creating a product, a mock product out of it, which you obviously are doing it at a smaller scale, and you try to get iterative testing done on the same, and finally you are able to come up with the finished product. Then on the optimization part is where you are doing these multiple iterations, you are identifying what works, what doesn't work, and then once you have identified all that, then comes your production at the larger scale, where once you have everything ready, that okay, this is the kind of product you should be launching, say orange flavored matcha juice, for example, right? Or say a matcha flavored cola, right? Now you have already came up with this concept, you prototype like one of the samples, you do like a small level testing, you identify what works, what doesn't work, you bring back the feedback, you optimize it, and then finally, once you have identified that okay, this is the point where the customer satisfaction is there, then you go ahead and start productionizing it. Now, breaking down the conceptualization part, which essentially is more about the new product development. Again, it can be broken down into two separate segments. One is the consumer need analysis. So consumer need, you can think of it in a way that it is what the need of the consumer is, right? Why people consume what they consume. For example, if I am having, say, an orange juice, maybe I want to satisfy my thirst, or maybe I am coming from a gym, or I'm needing it for the fitness reasons, right? So these are the needs of the consumer, or the consumer need, which can essentially be the sensory need, the functional need, or the emotional need. So the sensory needs are related to the taste, color, smell, texture of the product. The functional need is more related to the function of that product. How does that product help you in functioning? Is it giving you energy? Is it making you happy, etc.? And then finally, on the emotional side, where you have what is the emotional state of yours when you're consuming that product. Maybe you are feeling more energetic or more excited when you are having, say, Red Bull, or or it could be something which you like to have in isolation, say beer to yourself or something like that, right? So this is where the consumer need analysis is carried out. And again, the way FMCG companies today go about it is that they give a briefing to an agency, then the agency talks to 100 to 200 consumers. The recruitment of that sample itself takes anywhere between 2 to 4 weeks. Finally, they do a sample study. They have their own set of questionnaire where they essentially ask questions about, okay, will you like this product? They have their own set of questions, ranging from what do you think about the flavor of this product, what do you think about the packaging of this product, etc., etc. And then finally, on the basis of all that, they do the analysis and they come up with what are the consumer need this particular product is satisfying. Once they have done all that, they come up with the concept generation. The way you can think of a concept is what you see on an e-commerce channel, for example. When you go to any e-commerce website, say Amazon or a Coop, which is really popular in the Switzerland, for example, or the the German region, there you can see that for every product which is listed on the platform, you have a certain description about it, you have the image of the product, you have the name of the product, and then of course the SKU, price, etc. So all of that is essentially what a concept is, right? It's essentially what you're trying to sell to the consumers, that these are the different information about that product. Now, doing all of that, which currently happens manually, again, varies, because once you have identified the consumer need, you still need to create a product out of it. And that's where, again, they leverage another external agency or an internal team to, go through the briefing, then ideate on the same. And then finally, once they have identified it, then they try to have a mock screening of the concept, which again happens through a limited set of consumers, say 100 to 200 set of consumers, and then they try to identify whether this particular product is going to work in the market or not. So, and this entire process, anyway, takes between 3 to 6 months of this conceptualization part. This is another example where I have taken, say, uh, Granular Thailand and Kellogg's. So if Kellogg's wants to launch the next flavor of the granular in the Thailand market, how will they go about it currently? So firstly, they will try to identify the trends for the granular by talking to 50 to 200 consumers. The sample set again is either given or derived by the agency, or sometimes they only have their own connections using which they identify a sample set of the consumers. Uh, then they try to identify the consumer needs, which I talked about. They try to identify what the consumers are really looking out for. They also try to look at the demographics and the consumption setting. Again, it can be driven by the on-ground team, or it can be the external agency who is driving all of this. When it comes to the prediction, right? So let's say if Kellogg's finally has decided that they are going to launch, say, a dark forest granular into the market. Now they don't have any prediction metrics currently. It's many of the times it's more of a gut-based decision. Obviously, they have data to back it up when they are looking back, but they don't really know how it is going to perform in the future. And finally, the concept development achieve again, this part comes with the help of the internal design thinking session that they might have, or again, they might be leveraging certain external agencies. Uh, then coming on to the challenges of the CPG industries as a whole. So as you can see, what they really want to cut down on is the time. Time is of essence to them. And since the consumer needs are changing very, very fast, the consumer preferences are changing really, really fast, it becomes really important to launch the products faster, right? And so time is of essence to these companies. The second important factor for them is to create the successful product, because those 90% of the failure rate, which I talked about in the very beginning, out of those 50% of the product fail because they are not meeting any consumer need, right? Which essentially means that there was not any need of that product in the market, or the product was not able to sufficiently capture the need, existing need of the consumers for that market. So in the case of the granula itself, the dark forest granula, if we are coming up with that concept, it is a 50-50 chance that it is not able to capture the needs of the consumers. Again, based on the current method, this is what it boils down to. These two are the sample products which were launched. One of them is the Cheetos lip balm that was launched by the Cheetos company, and another one is Pepsi Atom. Pepsi Atom is very close to heart because it was launched in my home country, India. Pepsi did quite extensive work for this particular product. They did research in the 4 regions of India, from north, south, east, and west. They spent close to 1 million alone on doing a proper research about it, and in the different multiple cities they employed lots of sample set of the people, but ultimately the product bombed like anything. And what this means, or what this translates to, is that the current ways have their own limitations and they are not able to scale up. And now in the post-COVID world, the way the market research was being done previously also has to evolve. And not just this, the another challenge of CPG industry is the evolving competition. There are more startup threats that are coming on. Like, there are D2C brands which are directly having closer access to the consumers, and they are able to understand the consumer needs better. A classic example is the Dollar Shave Club, which came up with the subscription model for the shaving kit, right? And Unilever, in the very beginning, the Gillette brand, which they own, it really scoffed them, saying that, okay, they don't really have any business model and they won't be able to compete with the Gillette as a brand. But then, since they did not understand the consumer need properly, and Dollar Shaving Club, on the other hand, was able to successfully tap into the consumers that they will be open to the subscription model. They finally went on to become a unicorn and ultimately got acquired by Unilever itself. So I think that shows that how important it is for the CPG industry to understand this threat and, like, try to either employ these different technologies which are out there and rather embrace these technologies, and at the same time work with the startups who are already trying to do the same. So now I'll talk more about how the AI as a field has been evolving, and then what makes it possible, what makes this particular timestamp as the ripe time or the right time for the innovation in the FMCG product innovation space, right? So the first reason is that the 90% of the data which exists today was created in the last 2 years itself. And this data is going to increase by leaps and bounds in the coming years. One of the major reasons is, of course, the internet accessibility, which has really transformed not just the developed economies, but the developing and the underdeveloped economies. So the Southeast Asia region is a classic example where a lot of the users are directly moving to the mobile. Because of the mobile first internet, they are able to, like, get onto the internet as a platform and able to generate a lot of data, which is essentially a gold mine for any AI algorithm, right? And if you look at the data which used to exist a decade ago, I think there were few social platforms. There was very niche platforms that used to be there in terms of the data collection, even in terms of, say, restaurant delivery and like, the cab delivery and all that. Nothing used to be there. But now if you fast forward to 2020 and 2021, you can see a lot of the things have changed. The technology access has become really, really quick. With the click of a button, you can order a cab, you can order your food. And that's where a lot of the data is actually getting generated, which is helping the AI as a field to transform even better. Just to give an example, every second you have 1 million people who are logging into the Facebook, and then, like, the different stats related to all the social platforms, the retail platforms, the entertainment platforms, the search platforms, the gaming, and so on and so forth. The other reason, obviously, is the emergence of the cloud platform. We have seen how AWS really took head start in this particular space, and then Azure and Google were quick to follow it up. And especially GCP with its ML capabilities has been quite transformative. The way they have been, like, investing in the AI's applications and the AI spaces, and also at the same time improving the functionalities of their Google Cloud platform. I think that has been really commendable. At the same time, Amazon also has been coming up with a lot of the new features which are able to help the data scientists and the data engineers who are working on the core ML problems. Coming on to the AI applications in the CPG, right? So I talked a bit about the product development and sourcing, and this is where AI Palette is also essentially trying to tackle the problem. But at an overall level, what the problems translate to and how exactly AI can be used is the trend prediction, the ingredient discovery, or the DNA sequencing for supply chain traceability. On the manufacturing side, we are seeing a lot of the AI applications coming up, especially in terms of the robotic manufacturing or the predictive factory maintenance where it is being produced, or quality control. Then the classic ones which have been there for quite some time, but now are booming, obviously, with the incoming more data and more IoT devices that are coming into the picture. You have demand forecasting and micro fulfillment, etc. And then there's another transformation happening on the sales and the marketing, where you are getting better recommendation algorithms. You're getting a lot of the conversational AI in terms of the product discovery and the agents. A lot of the shelf intelligence is being driven by the computer vision algorithms. AI-enabled IoT devices are coming up. So a lot of the evolution is happening, and like I mentioned to you before, it's only becoming possible because of the data itself, and also of the way that we are able to work on this data, which is essentially the cloud platforms. So before moving on to the next section, I would like to essentially iterate or reiterate the word of the Ginny Rometty, who was the CEO of the IBM, and she essentially talks about that, how AI is essentially going to enhance Earth intelligence itself, right? So it's not there to replace us, or it's not there to take away our jobs, but rather than that, it is going to help us in the better decision making, and it will create new opportunities or new jobs out of the the existing ones, right? For example, the self-driving cars might be replacing the drivers, but at the same time they might create some new opportunities in terms of the the space. So I think that is what this particular quote is trying to capture. Now, coming on to the AI Pilot core offering. So like I mentioned to you before, we are playing in the product concept generation space, which is part science and part art, to be honest. But now with the AI capabilities that are coming up, especially in the generation part, and that is where we are able to build our solutions and cater to our customers. So AI Pilot essentially at an overall level is going to generate the the product concept, the new product concepts, leveraging the consumer needs and the brand personality. So what this means is, let's say if Pepsi tomorrow wants to launch a new drink for the Indonesia market or the Thailand market, a platform can tell them what kind of drink or the what kind of product concept they should be launching next in the market. And we do this by leveraging the consumer needs from the public data, and the brand personality and portfolio, etc., from the company data. So coming on to the AI pilot data, like what is this data that I'm talking about, right? How exactly we can leverage this data? So if you think about food, now food is one of the most popular topic online, right? People have to talk about food on social media, e-commerce, menus, recipes, etc. During the entire COVID time, I think it saw a huge boom in terms of the home cooking, because most of the people were cooking at home and couldn't really eat outside in the restaurants and other spaces. And that's where food is one of those industry which is very very basic. Like I mentioned before, it was one of those industries that was least hit by the COVID, and it continued to uh, boom for the and give a way to the FMCG companies. And coming on to the AI pilot data sources, so what are the sources on the public side that we really try to tap on? So this is an example of Thailand, where essentially we analyzed close to 6.8 million data points for 100 plus ingredient. So obviously we look at the social media, but then in addition to that, we also look at the search engines, the recipe and the review sites, the news and the discussion forums, and then finally the retail. So these are all the sources where you can find a lot of the food products. On the retail, you can find the finished food products. On the recipe and the review, you can find what is there happening in the cafes or in the restaurants or in the fine dining space. The news and the discussion forums can help you in understanding what exactly the consumers are really talking amongst themselves. Search can help you in understanding what people are really searching for, right? And then social media, of course, is where people have to post about what dish they are cooking or what kind of things are really coming up in the food space. And in terms of the technology, so now, this is one quote from Bill Gates, which he spoke about in the couple of years back, which is that the biggest breakthrough in AI is going to come when the computer can read and understand information like the humans do, right? Which essentially is what NLP is all about, right? And if you look at the world's top languages, there are more than 6,900 spoken languages, right? Uh, but there are the dominant 10 languages which 3 billion people out of the 7 billion speak. Again, these are the popular ones like the Mandarin, Urdu, English, Spanish, etc. And out of them, but on the internet, although we see English being the dominant language, but then of course Chinese or the Mandarin is not far behind, and then after that you have Spanish and the others languages. Now what this means is that you can't build your solution only for the English language, right? Because apart from the English, you can see there's a lot of languages which are out there. So whatever the NLP models that you're working on, they can't just be restricted to only English. And that is where the AI pilot is trying to transform that. We look at the NLP in the various languages that are out there. So we call ourselves language agnostic in the sense that we have the language specific models which are trained on the food related data set. So which means that we are not just restricted only to English, but we look at the difficult Asian languages like Thai, Korean, Mandarin, where you don't even have the English characters. But on top of it, we also look at the European languages, like the languages like German, French, etc., and of course the English and the others, right? And why this is important is because food is very, very local, right? If you think about food, the what people are having in Germany versus what people are having in France will be completely different. Similar is the case in Asian geographies as well, that whatever people are having in Indonesia will be completely different from what people are having in Thailand. And that's why it becomes really important to understand what the local people are talking about it by identifying and having your models which are able to understand the native languages, right? So that's where we do, whenever we are collecting the data, we try to make sure that the data is restricted to the native language of that particular region. And that's where we use the language detection capabilities. And on top of it, then we run our different models, which are able to identify the different entities, the sentiment, etc., from it. On top of it, we also look at the emojis sometimes because many on the social media, especially, people love to talk via emojis, right? And that's why it becomes really crucial to not just remove the emojis in the cleanup, but actually to include them so that it can help you in understanding what people are really talking about a particular food product for that matter. So coming on to the NER modeling, of course, you try to identify what are the different entities that are being talked about. You can identify what are the ingredient that is there, what is the consumer need that is being talked about, and other such details, right? So for example, in this particular case, you are interested in the dark chocolate granula because that is what is coming out. And then you can see chia seed is another ingredient which is going into the same. What are the different challenges? Well, NER itself is not that easy, and the complexity increases, of course, with the language. So, for example, in this particular case, you can see Apple CEO Tim Cook, who entered the conference podium while eating an apple. So now the entity needs to determine that, okay, this apple while is being talked about the fruit, and this particular apple is the company itself, right? So these are the challenges that we normally face when it comes to it. And the way we try to mitigate them is, of course, by training our data on the food related data set so that it is the more data we have on the food as a corpus, the better our algorithm will be able to identify the entities, the better algorithm will be able to classify it, the better algorithm will be able to give it a sentiment score for that matter. And then again, the challenge becomes tenfold when you start doing it for the different languages which are out there, and and while trying to do the aspect based sentiment in the non-English languages. So for example, this particular case, which is in Thai, it's talking about the best Wi-Fi and the ambience, but it's only for the Wi-Fi, but the food they are talking about in the worst sense. So if you look at the overall thing, then it might give it an average score or maybe even positive score, but that is not really the case. In this particular case, you need to do the aspect-based sentiment analysis to identify that this particular product is being talked about in a negative sense. The other challenge that we continuously face is the joint multilingual NLP, where you might have, say, English and Thai coming here together in one sentence. Now, this again becomes a challenge because usually the NLP models are supposed to be restricted to a single language when you're trying to work on it. But when you have these cases, that's where you need to split the data first and then run the separate model for the separate section. And again, in many of the languages or in many of the countries like Philippines, for example, people love to switch between the English and the Tagalog. So Tagalog is the native language of the Filipino people, and this is again becomes tricky because you have to maintain a model which can understand this mix sort of a language. A similar thing happens in India as well, where people use a lot of the English. English is nothing but Hindi plus English, where people use the Hindi, which is one of the scripts or the languages, but they use them with the Latin characters. So now, the transformation and everything becomes completely different. Although the meaning remains same when you read it, but like, the data set on which you have to train now has to be completely different. So these are the kind of complexities which you encounter when you're trying to do native language NLP. Then the other challenges which we face is, of course, in the image analytics. But I mean, I'll come on to the challenges later on. But the way how we leverage the computer vision algorithms is to understand more context and identify the insights. For example, it could be the age and the gender of what people are really consuming. It can be the occasion, like, whether it's a barbecue or it's a party, a COVID party in these cases, or even a Zoom party for that matter. Then the complementary food, right? What people are really having in complement with the in the different sections. Let's say they're having burger and coke or burger with fries, etc., etc. And that's where we have the different neural networks which are able to identify these the objects out of it. And of course, we have our own training models that we have built over the time by collecting more and more of this data. Many of the times, because we collect the data and we already have a textual information with it, we are able to easily label that. And then later on, we can use that as a training data set. The challenges which come, well, numerous challenges again on the image, because image might not be homogeneous in nature. For example, in this particular case, and this usually happens for Thailand, where a lot of the people have this fascination for naming their puppies or their pets with the food names. So a lot of the dogs or the cats will have the name, say Pepsi or Cola, etc., etc. So then it can give you a lot of false positives when you're trying to do this analysis, right? And even the best of the computer vision models can fail when you're trying to work on these problems. And that's where I think it becomes really bit challenging for us. But then again, who doesn't like challenges? So the team here at AI Palette has been consistently trying to build the models which are able to mitigate certain these challenges. Then the final part on the technology that we leverage into is the predictive analytics. Using the predictive analytics, we are able to identify how the trends are really going to pick up in the future. We have our own 39 unique factor, which come from the advisors and the domain understanding. And using this, we try to predict the AI palette coffee trends in the 2019. And surprisingly, most of our predictions were on point. Again, these predictions can be vastly affected by any black swan event. But of course, if the things are running smoothly per se, then these 39 unique factors are pretty much good indicator of how the trend is going to go in the future. So while we don't give you month by month analysis, we will be able to give you an idea of how this trend is going to go up or down or remain constant in the future. Again, the challenging part is the onset of the black swan event, which can make all of your predictions go out of the window. And of course, the events like COVID-19 are once in a lifetime event, which can definitely screw up any prediction model that is out there. Right. So I think that's pretty much it. I have this last slide for the audience to help them in kickstarting their career in data science, if any data science enthusiasts are listening to it. So I think it's all about breathing and living the AI in what you do. If you remember, one of my earlier slides talked about how you are using AI without realizing that you are using it, right? So I think the bottom line should be you try to understand it, that every day in life, how exactly AI is helping you in making your decisions, and then try to understand the science behind it, the mathematics behind it. The best way is to go about the different, the literature that is already out there. So Introduction to Machine Learning by Andrew Ng is a very fantastic course that you can do on the Coursera. There are multiple MOOCs which are available on the Coursera, edX, and Udemy. On top of it, you should definitely brush up your Python skills, your cloud computing skills, because building a model is definitely one thing, but then I think it's really crucial to understand how exactly it is being deployed. And I think that's a very useful skill, because then you don't really need to rely upon the DevOps team. You can yourself do the deployment, understand where exactly the blocker is, and make it more parallelizable or in the processing part. On top of it, you can try out the open source projects which are out there. Fantastic work is being done in all of the different spaces. Many of the major companies themselves, like the Google and the Facebook, are coming out with the open source projects, and I think that is where you can start contributing. Then there are certain apprenticeship programs. If anybody is listening from the Singapore, there's this AI Singapore program. I'm sure these programs are out there all over the world. So I think that also definitely helps you a lot. Working as an intern in the early stage AI startups, I think that's really important and crucial, because I think once you start working in these AI startups, you will get pretty much hands-on experience, which you might not be able to get in a very big company. And for example, couple of our interns actually started working on the NLP, and now they are actually converted into full-time employees with us. And I think that's how you are able to grow together with the company. As and when the startup is growing, you are also able to grow in your role. And I think it's a very easy way to understand the application of AI if you're really looking for that kind of work. Then finally, it's all about the blogs, the forums, and the discussions, news, etc. LinkedIn has multiple fantastic sources. I think the Data Clubs is another one fantastic platform which can help you in understanding all these discussions, or it provides a forum for the same. Similarly, on the Medium, there are different blogs. Towards Data Science is one of the major one which I subscribe to. Then the other one is, of course, the meetups and the conferences to attend the which you can attend to meet the like-minded people. Of course, in the post-COVID world, most of these things have shifted online, which actually helps you because now you don't even need to travel to a different country or a place. You can sitting in the Germany, you can listen to the speakers from Singapore, like in this case, or vice versa for that matter. So I think this is definitely going to democratize the way education is being accessed or the information is being shared. And I think we'll see a lot of these virtual conferences becoming a part of our daily lives. And then finally, the cold reach out to the experts on LinkedIn, or going out on a coffee or having an online meeting with them. Of course, this will have a high failure rate, but then again, you don't really need 100% success rate on this. Even if one person out of the 100 that you approach helps you out, I think that will be worth the effort. And I think many of the people on LinkedIn community, especially in the data science space, are happy to help each other out. And I think that's also one of the ways in which you can leverage the fantastic network that is already out there. So I guess okay, this is more information about the AI pilot. Yeah, you can definitely follow us on Medium and LinkedIn for the work that we are doing. You can go through our blogs where we have written about some of our data science work in the NER space, the predictive modeling, etc. Yeah, and I guess that's pretty much it. I'll stop sharing now. And yeah, Alexi, I hope I did not bore you guys.
Yeah, we have a couple of questions. Thanks a lot for presenting. That was interesting. To me, before I started with questions, I found that all these things like design thinking, product management that I'm used to seeing at work,
Right.
at IT companies, I just realized just today, when listening to your talk, that it's actually coming from, this old-fashioned, not internet products, right? All this like market validation, all these steps.
Right.
Complex there, like that. The amount of time you need to spend to do market research and all that is it's a lot harder to do that in the physical world than on the internet. Like on the internet, you just go ahead and change a button and then experiment, right? But here it's
I know. Yeah. I think that's one of the biggest challenges, I think, with the CPG industry, and especially in a post-COVID world where now you can't really do like a survey like you used to do before, and then finding that the set of the sample people who are not truly representative of the entire population, and then at the same time you want to crunch down the time, right? You want to reduce the time in launching a product. So I think all these multiple challenges are forcing them to adopt the digital solutions. And I think that's where a lot of the adoption is happening in the AI, because a lot of the data is already out there. It's not being leveraged to the full usage. And I think that's where AI can play a very dominant role in the coming years for the CPG industry.
And that brings us to a question we have about data sets.
Okay.
So I think you did mention that you did answer this question. What are the public data sets with consumer needs that you use, and how we can access them? So I think you did answer that, like you basically use social media. right?
Right. So it's a combination of the different sources. Social media is of course one of the major ones. Then on top of it, we also look at the food review sites or the recipes platforms, and the e-commerce channels also wherever the food products are being talked about. Since we are majorly focused on that, search data is another important like data set that we leverage. So it's a combination of the different
Okay.
sources, I would say, and then the collection again happens through either if you have the API for that particular platform, then you subscribe to the API. If the API is not there, then you either use a third-party data provider or you use some sort of a web scraping to get the data. So it's a combination of all that.
Just curious, follow-up question on that from me personally.
Mhm.
Like, let's say you get this Twitter stream or Instagram stream with data, but then you need to understand which post is about food and which is not. I assume you have some sort of a binary
Right.
classification model there, or
Right.
how
A
does it
good
work?
point. So the good thing about the the Instagram itself as a platform is that it has this capability of the hashtags. Right now, using the hashtags, we are able to, when we are collecting the data, we are looking for the hashtags which are related to the food, of course. But on top of it, once the data comes, we have our own cleaning modules which are able to clean the data and make sure that this data is only related to the food. We have our own tagging algorithms, like you rightly mentioned, the binary classification. It is able to identify whether this is a is beverage or whether is this is snack, etc., etc. You have the different food categories which are out there. So yes, we have that model which is able to essentially classify and give it a rating that okay, this is a food related data set.
And how many images with dogs that looks like Coca-Cola bottles do you have?
I think that was a isolated issue for the Thailand market, especially.
Okay.
I think Thailand was like crazy because people dress up their pets in weird things, and we saw all these cases, like all these false positive coming up, and from there, because we saw like cola seem like a growing trend, or rather like an emerging trend with like a lot of posts coming up, and this kind of confused us because cola, if you think about it, it's a very mature trend, right? It has been there since ages. There's not much innovation currently happening in the cola. Of course, in the other space it is happening. And I think that is where the tipping point came. And then we decided to actually go through the underlying data. And that's where we started realizing, okay, I mean, our model needed certain retuning and all. And yeah, I think it was quite huge, I think. And that's where we have now tried to fit in certain criteria that we augmented with the textual data. For example, in the textual data, they might express an emoji which is related to a dog, for example, or maybe they will express something like a nickname of the dog, or sometimes they can even put in like say hashtag puppy or hashtag dog. So then we are able to filter out those using the textual information which is related to the image rather than from the image itself.
But that was a memorable picture.
Yeah, I know.
Yeah, so the next question we have is trends in food represents consumer needs that are already met. So people tweet about good coffee they already bought. How does one find unmet consumer needs?
Right. That's a pretty good question. So the way the food trends essentially flow. So FMCG companies or the CPG companies are not the innovators of the food. The real innovators of the food are the chefs, the baristas, and the bartenders. So these are the people in the the food industry who essentially come up with a new combination, a new dish, or a new mocktail or a cocktail for that matter, right? And once a thing gets popular in the restaurant space or in the fine dining space or at the home cooking space, that is when it gets adopted by the QSR space. So QSR is the quick service restaurant, the companies like McDonald's, KFC, Starbucks, etc. So then they try to adopt the trends. And then finally, once a trend becomes hugely popular in the KFC and all of this QSR space, that is that is when it essentially gets transferred or gets picked up by the CPG companies, right? So, and as you can see, it takes a bit of a time for the trend for the CPG companies to essentially identify that this particular trend or this particular consumer need has actually become huge. What AI Pilot is trying to do is we are looking at the source itself. So as and when the trends are becoming popular in the culinary space or in the home cooking space, etc., we are able to identify the consumer needs from there, which are in the market, but at a very small level, right? It has not become hugely popular, but it's there at the cusp of it. And then using our own models, which are able to look at how that ingredient, how the other related ingredients have performed in the past, how that particular, what kind of need that particular that particular ingredient is satisfying, etc., etc. We are able to give it a prediction score, or we are able to identify that, okay, whether this particular consumer need is going to be met or not in the market, or whether this particular product or the ingredient is going to satisfy a white space opportunity for that market or not. So I hope I answered the question.
Yes. Thank you. I was just trying to find my unmute button to be able to to ask the next question. Thanks. So are there more specific parts of the CPG generation process that are mainly responsible for the failure of the product?
Right. So I think on top of apart from the understanding of the consumer needs, I think a lot of the time the failure happens to communicate the product, right? So like essentially the marketing part of it. So many of the time the companies are not able to essentially sell the product or sell the USPs of the product, so to speak, right? So what I mean by that is, like, a particular product, what are the benefits of it? So many of the times, all of this is being done in a manual manner, where people are coming up with the write-ups and all, but then they don't really know whether that write-up actually attracts the consumers or not, because once again, that write-up is tested on a sample set of consumers, right? And they don't really know whether these words are actually striking a chord with their audience. And that's where, like, again, how the OpenAI GPT-3 or the other such technologies which are coming up can really leverage, because they have been trained on a data set which is like hugely there. And let's say if you train it on the past successful product concepts that were there, then you can essentially generate a description which involves, or which, like, kind of includes the parameters which already were successful in the past. So it's like, imbibing the right words or the right keywords, and then giving it out as a, like, a marketing campaign or a chapter or whatever. So I think that is where a lot of the work has now started happening. We can already see certain startups that are coming up, especially with this whole revolution which happened in the GPT-2 and GPT-3. And I think that's going to be another interesting space on how you can generate ads at scale, how you can generate the ads with the right language so as to strike a chord with your audience. Like, how do you explain the USP part to them? So I think that is going to be something which will be very interesting in the coming future.
Yeah, indeed. Then the next question I think you'll find interesting. So once AI is fully adopted for this process, can Reddit community coordinate to trick a company to launch a certain product?
Right. Okay. Right. Yeah, possibly. I won't be surprised. I mean, uh, the way that they can, I mean, I am not sure if they can trick a big company, but they can definitely, I mean, like, have their, yeah, or, I mean, even a big company for that matter, right? So for example, like, if they start playing around with the stock of a particular company, for that matter, a publicly listed company, and they can definitely pressurize them into, like, launching a particular product. Or many of the times, I think on the platforms like Twitter, you are seeing these petitions being launched, right, to launch a particular, or to bring back something from the past. I remember there was this, I think in one of the countries, I forgot the name, where a petition was filed to bring back the fries in the McDonald's, right? So, and people were like, and similarly, there was another one to bring a sauce in the KFC. I think it was some specific sauce which was there. So I think, yes, people in the past have tried ways to, like, bring back, because I think food is something which is very close to heart for the people, right? People love to talk passionately about food. I think there are millions of foodies that are around the world, and it is a basic need of the human being, right? And it will continue to be there for the generations ahead. So I think it is definitely like, there's a possibility in the future that, people are able to communicate with the big brands directly, and then, like, have their consumer needs directly satisfied, either through the channels, or, like, or through, like, a channel like Reddit or Twitter or whatever for that matter.
Or tricking the algorithms.
Or tricking the algorithm, yeah.
Okay, we do not have any more questions. So unless a new question pops up right now, I would like to thank you for coming today. Well, joining remotely from Singapore. Maybe last question, you mentioned like on the last slide, you had this nice list of what people can do to get into
Right.
AI and data science. And
Right.
you mentioned interns. Are you hiring interns right now?
Yeah, definitely. I mean, we continue to hire any point of time if we find someone who is like really passionate about the AI and especially about the food. I think we are more than happy to talk and like
Mhm.
accommodate them because as you can see there are like a lot of applications, not just in the NLP space but in the computer vision space, the prediction part, and also yeah, if we come across someone good and who is really passionate, we will be more than happy to talk.
Mhm. And are you remote or like the person needs to be
Uh,
in Singapore?
Right. So in Singapore, fortunately, since the COVID situation is under control, so we have started coming back to office. Right now, I'm actually in my office,
Yeah,
and
just
yeah. And for the India team that we have right now, they are working remotely because
Mhm.
I think India, the situation is still not there yet. I think it's going to take some time
Mhm.
before we can reopen our India office. But yeah, at the same time, if someone is like really good, we would be more than happy to have him as remote as well. There's no barrier as long as the the person is dedicated enough.
Okay, I will share the links to your website, so you can just
Sure,
find it in
sure.
chat. And it's
Yep.
aipalette dot what
Com.
com org.
Yeah, aipilot.com. Yeah.
Okay, yeah, I'll
Yeah.
put the link in YouTube chat.
Yeah.
And
Yeah. Yeah.
that's all. Thanks a lot for coming and sharing it with
Yeah.
us.
Yeah. Thank you
And
so much, Alexei, for the opportunity. And I hope it was useful for the audience. And yeah, and thank you for having this platform. I think it really is much needed in this age of the applications of AI and AI as an evolving field. And yeah, good luck to you for the future sessions.
thank you. Okay,
Yeah.
we'll have a short
Mhm.
break now, 7 minutes before the
Okay. Bye
new
bye.
yeah, goodbye. Before the
Cool.
new speaker joins. So see you soon. Hi.
Yes, hi.
Can you see me, hear me well?
Yes, I see you well and hear you well. You too?
Yes, yes. Do you want to try to share your screen?
Yes. You need to stop, I think, yeah, it's good. So you see it now?
Yes.
Okay, just make a present.
Yeah, so we have a break now. We will start in 3-4 minutes. So I'll be right back.
Yeah, okay.
Hello.
Yes, no?
So I think we can start if you're ready.
Yes, I'm ready.
Yeah, thanks for coming over and for your presentation that you're going to do. Yeah, so yeah, I think let's start. The floor is yours.
Okay. So thank us for your session today and for this opportunity. This is Mahmoud. I am founder and CEO of Division X. I have 8 years experience in building machine vision systems, especially with AI for industrial sector, especially for quality inspection use cases. Recently, we started Division X in 2016, building AI machine vision systems. And now I will go through what is machine vision systems and also quality inspection, but with industrial use cases, going to no-code AutoML system and what we have in our new tool. It's called Tuba. So let's start. I will start now with what is machine vision systems and what's the difference between machine vision and the computer vision. If you think computer vision is only the code or what you build based on software to make analysis or make some getting some data from video or images. But when we think in building a machine vision system, it's about building the whole system, including hardware parts. So how you get the images, or how to feed the system with images, how to capture the images and lighting effect, and the processing part, and also the moving parts. So if we imagine this design on the screen, you will find something like a sheet. Can be textile, plastic, metals, any type of sheets. We have cameras here. We have something of related to lighting. Lighting may be under it or above it. It can include different types of cameras, like normal visual cameras, infrared cameras, and the other cameras. All of this type of hardware sets affects on what you build encoding. So when you have for example, some cases we need, if we have metal sheets, so we need to use infrared cameras to avoid reflection, as example. So it will affect on what you are write in the coding. So when we need to call a machine vision, it's about building the whole system, building the all hardware sets suitable for the use case, and also building the coding type that may be classic computer vision coding or AI based, is suitable for this case and for this types of imaging feeding. So when we go in the problem itself or the challenges that we face, like human inspectors in manufacturing entities with their eyes, lead to low accuracy and high cost in operation, especially high cost of human inspectors, especially in some niche sectors, leading to method standards revolt and also unused large volume of data. So what we need to do here is to build automate the quality inspection systems by using cameras and other software behind the cameras. So we automating the inspection process itself. We have real-time data management with standard data sizes or databases or reports and something like that, and also adding AI and deep learning with increased accuracy itself, in addition to make the systems more flexible to work on different types of product in the same time. So it is some of operations that we can do in this idea. So we can verification, classification, problems, identification. Part of it are gouging, especially for 3D imaging, inspection, and also counting. This is some examples of what operation can be done and or what's the problem cases can be solved. When we go here, so we have a traditional machine vision system written by traditional coding systems like image capturing, something like feature extraction, and also make decisions based on this extraction. This is the classic pipeline that can be done. But when you go to AI based, so just train the model with the images. So we need the volume of images to train these models, and also make some prediction and results for this. And building two types of systems, so we mix it between them or have this only. This is the effect having on how to build a machine vision system. And especially for this, you can consider this samples of leather or textile. So we have different type of problems. So we can classify images between good and other defects. Then we can detection where is the defect in each image, and also we can segment the defect from the background. All this operation needed to be done in any quality inspection system. We can do one or do all to have different types of quality inspection skills. So we can only classify between good and bad. We can or we need to define which is the defect itself, and also which is place in the image that can reflect it after that in the whole sheet or object, and segment it or separate it from the background. So why we need to automate the quality inspection process? So it's lead to high quality, so need to high prices. This is from business value of it in the manufacturing sector. Lead to a big volume of data that can be reflected to helpful insights and increase ROI. Better quality is in strength the brand itself, and also different qualities standard or different prices or different classes of the products. So we'll go there in some use cases from some sectors. For example, we'll go to the food and beverage sector. And here we can talk about caps and bottle caps. It can be to test the sealing of caps. It's made with infrared imaging. Some examples of sorting, for example, bread sorting here, and sorting is very good application, especially for fresh food, for fresh vegetables and fruits sorting. The fresh food that you buy in your market, it can be sorted with colors, sizes, and also out scratches or out defects. Also, we can read something like expiry date and is any other printing material here. Then we'll go through to pharmaceutical. The famous application in pharmaceutical is about track and trace, to track and trace the medicine packages itself. So this barcode and any other text written with this QR or barcode. Inline printing inspection, artwork inspection, artwork or the whole the packages itself, packaging, and also verifying the bottles and what is contained. In automotive, as examples, welding inspection, especially X-ray images of welding inspection, maybe have the gouging to volume check of the cylinders, power steering assembly, and the coating inspection. In coating, we can use sometimes visual to inspect the visual parts, and also it can be infrared too. Stamping and the body parts reading, something like that. In electronics too, it is famous application like PCB quality inspection, soldering inspection, and the component placing on the PCBs, and wafer inspection too. Other applications in plastic like gouging and the plastic sheets inspection, something like that. It can be infrared, also can be by visual too, and BBT code data confirmation. It is a use case, a real use case from Midwest Plastic in USA. They have they will have a problem to make the inspection process. So every time operator stops the line and they take a sample to make some inspection, so they wanted to replace this process by automated process on the whole time. So they use a line scan camera with LED line scan lightning and industrial BBC to automate the whole process. So after 6 months of using this system paid for itself as a ROI, and also reducing the production material waste that represents 60% of the cost. So this is the real business value of using this type of automating the quality inspection system based on machine vision and AI. Okay, what's after else? In this point, we have some use cases or some examples from big corporates like GM and B&G that already have a built-in machine vision system in the whole production line in this system. So, for example, in General Motors, they have 2,000 plus smart cameras that have 2 million plus inspection per day and have 1 million plus data sets uploaded daily. There's a big volume of data. It's need a new thinking and a new approach of using this type of data. So they need to automate the image analysis itself, and also what about deep learning on distributed system that they want. On the other hand, in B&G, they have multiple and different types of products worldwide. So they need a simple systems to be simple as using mobile apps on smartphones, and also something to reconfigure and re-engineer to use it on different types of product and data, and the flexibility that avoids them to approaching technology provider to make it for each product. So this is the reason that we built Tuba. It's about no code techniques and also AutoML together to enable the manufacturing sector to build their own AI machine vision systems or computer vision apps by themselves without any coding or AI experience. So we'll go to the traditional machine vision workflow here. Anyone, I think you are maybe aware of this. So the developer go through this process to generate the model to use it. But in AutoML workflow, just feeding the system with the data or images in our cases, and then make the prediction, and go as a no-code interfaces to avoid all this parts. So this how it works. It's about feeding system by images, make the labeling part, and make the training part that including different types of operations like classification, detection, and segmentation. Then generate dashboards for prediction or testing, and also can export different types of models, and also generate APIs. These models can be now there's for example there's a deep learning based cameras, the cameras including GPU or FPGAs that can only put your model on it and just run the system. So we reach now to a seamless end-to-end system that the user can use it. Just feed the image and then generate the model. So it's something like building the model on Tuba, integration with deep learning based cameras, and also integration with software or apps or solution according to deployed models or API, already made APIs. So after the whole of that, why we need to use Tuba, or why we need to use no code or AutoML tools? So we have different types of deployment options: the AutoML end-to-end solution and the no code on cloud and on-premise solution, and also your team will make it by yourself. So we'll go here in the build versus buy. Why the manufacturing sectors now need to build their own systems instead of buy a ready-made solution. It's about design the system by themselves, as the expert in the field is the most one near how to solve it. Simplify the setup, greater control, and the most famous area is about reconfiguration and re-engineering the systems to be or to work on different types of products, and integratable parts that you can generate models that can both on cloud and also both on the edge according to the needs of it. Okay, thank you. I finished my presentation now. Any questions?
That was quite fast. Yeah. So I just want to remind that if you want to ask any question, there is a link in YouTube chat that you can just go and ask. Yeah, do you maybe have some sort of demo, like how it looks like, what, like how people can use this tool to simplify all this process?
Okay. Maybe I don't have screens for it,
Mm-hmm.
but I
But how
can.
does it look?
Yeah, I can explain it here. Yeah, in this one.
Mm-hmm.
For example, if you have, I will give a real example. Um, uh, um, we have a use case in with X-ray images of metal tubes. So we have a good images and bad images, and all of them together. So first step two, we need to feed the image to the system. So you upload these images and then go to the labeling process, put the labels, and generate the label data set. All of this coming through interfaces. Then you will choose the training type. You need to make classification or detection or segmentation based on your labeling part. There's some configuration here made in training. Then start your training. The system will make a different types. It is a concept of AutoML, make a different types of models, and then choose the best one of them. Then after the system automatically finishes the training, it will notify you to start the next step. It's about testing. The model will be deployed on the system, and you can feed the model with images to make some tests if it's okay for you. So it is done. So you can generate the model. You can export it as I think the example was on exporting. So you can get it with TensorFlow based or other types of extension. Then you take the model, put it on the camera or put it on Judson board, for example, or put it in your application itself. This is other part. Or you can test it using API. So you can take the link and open your application and feed the system with images. So from this we have the whole process. The user can go into interfaces to show it or to make it by themselves, then generate this. From here, you can consider that it is helps the user to accelerate the prototyping process as a first part, and then they can use the same system to build the final model that can be used on the final system or on production.
Okay, that simplifies the process a lot, and it can be used for most of the cases you showed. Like basically, when we have like this production line, we in all these cases we can use this, right, for automating our
Yes,
decisions.
it can be used for most of quality inspection cases. That's depending on 2D images. Even if images is visual or infrared, it is the same. Just collecting the images and feeding the system and generating the model by it.
So basically, let's say I remember one of the examples was about bread. So I assume that there is some line with bread, and then so basically you take pictures of bread.
Yes.
Yeah, here this one. So you take like as bread goes on the line. So there is a thing that takes pictures at certain interval, right? I don't know, every minute or something like that, right? And then you basically put these um, to this model, and then the model detects the defects, right?
Yes, the effects, and then the camera or the system can generate control signal. This signal can control the line itself
Okay.
to filter the good bread from the bad bread.
Okay. So like the moment it detects bad bread, so what happens? Like there is a alarm and then alert, and then people come and take the bread away, or how does it work?
It's possible, but it is now it is not the fully automated. So the fully automated system that after there's other mechanical part. So after the camera detect or the system detect that we have here a bad bread, so there's a mechanical system that filter it, reject or going to the good one. So it is going sorting, filtering them separately, automatically, and it is going to a very high speed. It's not all one. So for these cases, we have some cameras with a very high rate frame per second, maybe reach to 300 or more than that. And for these cases, we need to have a very high processing units, especially embedded one, to have this speed in response.
Okay. And I'm just curious, like, about the infrastructure. So these things, like, do you do on-device computation, or you send the pictures to the cloud somewhere for scoring?
No, I think it is make on online is AI on the edge to avoid any problem and the internet connections and the cloud systems,
Yeah, okay.
and to make it very quick as we can to avoid any delay in the response.
Okay, makes sense. And you mentioned you use TensorFlow, so I assume you use TensorFlow Lite for that to do this on devices, right?
Yeah, some with TensorFlow Lite and some for maybe for JSON boards from NVIDIA. Yeah.
Okay, okay. We have a question. Is the defect classification performance better than that of a human?
Yes, and according to the case, which I mean that when we have a constant human factor error, it's constant according to the human depending on it. So in these systems, the human factor error is 0, so we avoid all of this. But maybe we in some cases, in some special cases, the human existing is more important than systems. Maybe it is in some cases. So the AI systems trying now to learn from the human. So if we have expert in making an inspection for metal tubes of its X-ray output, now we can use this human experience to learn the system. How he will take the images and make the labeling of it, and then will feed and train the models, and he by himself he will evaluate the model performance if it's going well or not. And for this reason, we choose to have enabling approach for the manufacturing sector instead of building the whole solution for them to help them to solve these very special problems.
Okay, makes sense. Is there any legal accountability for misclassified samples if defects can lead to safety problems?
Safety problems.
Like legal like in the sense that let's say like the system misclassified something, right? So it says, okay, this is safe, but it's not, and you know, a spoiled bread goes to production, like to people. Do you like can you have any legal problems, legal accountability because of that?
For all cases that as we have before, we didn't face something like that, as we are working for corporates to improve their quality, to improve their existing and the reputation in the market, and not for legal reason. But we found some others, especially in some sectors like pharmaceutical. They may use some inspection systems to, for example, to make some metal detector. For example, I found a case with a client that they have some metals particles, small metal particles in the pills. So need something to make metal inspection. This coming from the government, that the government make enforce the whole companies to have metal inspection, automated metal inspection process on their production line. It's something like that. So I think the legal point is going to the sensitive industries, especially in pharmaceutical one.
Yeah, makes sense. Thank you. Yeah, so We don't have any more questions, but yeah, so now is the best time to ask a question. And there is a short delay between the time we talk and the stream on YouTube, like 10-15 seconds. So let's wait for a bit of time, and unless there are no questions, then yeah, maybe in the meantime, can you tell us how we can find you?
Yes, you can send me by email. Is here, and also you can find me on LinkedIn. Yeah.
Okay, and on DataTalks Club as well.
Yes.
Okay, it seems we do not have any more questions, but if you have any questions at a later point of time, or maybe you watch it as a YouTube video later, these are the contact details. And thanks a lot for coming and sharing this. So I imagine that this is not an easy project to do, like in manufacture. So this is not a usual internet project where we have
Yes.
everything under
Not easy.
control. So thanks for telling us about that. And now we will have a break, like half an hour, and we will come back in 5 p.m. Central European time. And thanks a lot, and see you soon.
Okay, bye-bye.
Goodbye. Hello.
Hello.
Hi, you're here.
Just give me a minute.
Yeah, we have 8.
Wait a minute.
Oh,
I'm seeing this on. Were you playing the YouTube video? Because I hear like a 1 minute later echo. Oh no, I'm
are
watching the
you?
YouTube video.
You're so you need to mute it, and there is a
Yeah, okay,
delay
okay.
of like 10, 20 seconds, something like that.
Yeah, I
Or
see. Yeah,
15.
I hear what I know what you mean now. I'm gonna mute
Yeah,
it.
so I have the video, and it's on mute. So right
Okay.
now only 12 people are watching. So I think because it's a break, so I think they will come back in 7 minutes.
Yeah, no problem. I think it's also it's been a long conference, 3 hours. So
Yeah. So yeah, the last talk finished a bit earlier, so I could enjoy a little break.
okay. I'm gonna pull up my slides and you can tell me what's the best way to share it. So
So these buildings behind you, they are so tall.
yeah, these are all apartments. I live somewhere near downtown. Give me a second. Full screen mode. Can you see this correctly?
Well, I can see that machine learning in here, so I don't
Healthcare.
see the rest.
Oh,
Yeah,
really?
but I don't see the rest. Yes, I just
How about this then? Can you see?
now in health.
Oh, even in full screen mode, you can't see it.
Okay, now I can see it.
Okay, I guess I'll have to stick to this then.
But if you do full screen mode,
Uh, I did full screen mode just now. Give me a second. I'm gonna
was it?
try.
So maybe you were sharing just not entire screen, but just one window.
How do I share the entire screen?
I don't know. Do you use the app or browser?
I'm using the app.
Okay, and it like when you press share the screen, it asks if you want to share the entire screen or a specific window,
No,
and I
it's
just usually
asked.
select.
It asks for the. Oh, okay. Let me try this. Share desktop. How about this? Can you see it in the full screen?
Now, yes.
Now it's full screen. Do you
Now it is
also
full screen.
see?
Yes.
Do you also see my face and your face as part of my Zoom, or is that
Yes.
only me? You also see that?
It's only you, but I
Oh, okay. It's
see.
only me.
Yes, but I have
Okay.
also my own.
Okay. No problem. I just want to make sure that the audience can
Yeah, but
see
if you
everything
check
properly.
how it's visible on YouTube, so there is like it's in the top right corner.
Oh, okay. That's fine then. Yeah, yeah, I guess you can see me looking at YouTube now as well. Yeah, it's okay. Okay, we can start. I mean, just let me know when is a good time to start.
So
Happy to.
we still like we're still on break, so in 4 minutes.
Yeah.
So
Alex, I'm just gonna quickly go over the slides, just a few
yeah, sure.
slides. Can you see this?
Yes.
Okay, yeah. How's the conference been so far? I'm sorry I didn't attend. I was sleeping.
Sleeping. Yeah, it was fine. Last talk was a bit fast, a bit quick. I was a bit surprised when it finished.
Yeah, don't worry. This is the last time I go through this is about 30, 45 minutes. And I think there'll be more if we allow for questions as well. So I mean, if I could trouble you to, just if there are any questions in YouTube or Slido that you think are relevant at that point in the slide,
Okay.
Please feel free to just stop me. Yeah.
Okay. Yeah, but in general, I would wait till the end of the presentation, unless it's super relevant.
Yeah.
So I also noticed that there is some delay. I don't know if it really matters or not.
Yeah. Makes sense.
Yeah, the integration with YouTube was surprisingly simple. So I just clicked the button stream on YouTube. Then I created a name of the talk, then another click, and that was all.
That's why everyone uses Zoom, right? Because it's simple.
Yeah. It's not the cheapest thing.
Yeah.
Like there are cheaper things then, but it's quite easy.
I see.
It's convenient. This is something we use at work also, so I don't need to install anything else. I can just have one app.
Nice.
How many slides do you have?
Not a lot. I think the first 10 are going to go by very fast. Then after that, it will maybe about 3 to 4 minutes per slide. So it's about 20, 25 in total.
Okay. Yeah, I'm excited to see.
Yeah, I hope it will be interesting for the audience.
I'm sure it will be.
Let me see. Do I need to turn on this light?
Well, your face is quite tiny. Like it's not really.
How
like
about
it
this?
doesn't really matter what I'm trying to say.
Okay. Yeah, because I pull up the blinds to try to let some daylight in. I thought that would be a bit better. But at least the sun is setting earlier now that winter is over. Yeah. No, I mean rising earlier now that winter is over.
Yeah. So every time I invite somebody from your time zone, I feel a bit bad because they have to wake up so early.
It can't be helped.
Yes. And now we get more and more guests from the States, from the West Coast.
Yeah.
Okay. Yeah. 1 more minute and we can start. I'm a bit worried that where all the people are, because it was like 40 people who were watching. Now it's only 9.
Yeah, I guess it's
towards. Sorry.
It's towards the end of the conference. I mean, even in a regular conference, towards the end, most people don't stay. Yeah.
But I will put that separately as a separate video afterwards.
Yes, no problem.
After the conference. Okay, it's 5 p.m. now. So we can. I don't know if you want to wait more or we can just start.
No, it's okay. I mean, I just want to ask a question to the people who are in the audience. If you're actually listening, my question is, for the people who are in the audience, what level are you at? Do I need to talk about how to prepare data, how to split data, or are you more interested in the system design? What questions are you interested in? If you could just type in the live chat on YouTube, that would be great for me to help understand how to better say, how to better ask you questions. I'm gonna ask as well, but I don't know, maybe people might be AFK, yeah, or they might have fallen asleep after a very long day of conferencing.
I haven't, but I have to be awake.
Yeah. It's okay, we'll just give it a minute or two. Oh wow, it's only now that it's switching to my YouTube.
Yeah, there is a delay like 10, 20 seconds.
Yeah, 10, 20 seconds.
I don't know what exactly, but it feels like it's less than 30 for sure.
Yeah. No problem. I mean, I've left the questions in there, and we can just see how it goes.
Yeah. So from me, from my point of view, all the things you mentioned are interesting. So I don't know if you can cover all of them or if you're going to cover, but if you can, that would be awesome.
I'm going to sort of cover all of them. Just that I just want to know where I should go deeper into. Yeah, but we can see. I mean, if the audience has any questions, feel free to just post it on Slido or on the YouTube live stream itself. Okay, cool. So today I'm going to be sharing about machine learning in healthcare. It's a very specific aspect of machine learning in healthcare. What we try to do is to try to build a cost prediction system for Southeast Asia's largest hospital group. So let's just jump into that. So this is what we built. We launched it a while ago. It's a estimation system. So I mean, they call it AI powered predictive, whatever. But this system, since then, we have been able to put it online. It's consistent uptime. It's reliable enough for them to start providing fixed cost surgical procedures for some procedures. So in the sense that we're able to just use this and just provide fixed cost procedures. So why is hospitalization cost prediction important? So I think in Southeast Asia, this is where Singapore is. It's one of the most expensive in Southeast Asia. Of course, can't compare to the United States, which is all the way up here. And you know, Singapore is very, very high on medical inflation. It's 10% in 2019. And the biggest cause of it, the biggest uncertainty part of it is hospitalization for our patients. So that is what these hospitals are trying to provide patients with a bit more certainty on. They want to provide them with upfront cost estimates so that we can improve the patient's experience and also retention. So what we found is that, hey, you know, when providers provide upfront cost estimates, it's easier to attract the patients because they have a bit more certainty. It is not a guarantee, but they have a bit more certainty on what the procedure or what the treatment is going to cost them. And you can see the citation is here. Oh, sorry. And of course, for the patients, providing them a view of the potential bill reduces payment challenges with providers. What this means is that, hey, someone might want to come to get a specific surgery, but if they don't know how much it's going to cost, it might cost a lot more than they expect to, and they might just go ahead with the surgical procedure without knowing cost. And what happens is that at the end, they are not able to pay for it. So this is not good for patients, as well as it's not good for providers because they are out of the pocket. The doctor's time has been spent, the surgical procedure, the operating room has been rented, and all the materials have been used, but no one's going to pay for it. So let's start with the problem. The problem is, or rather, let's start with the intent. The intent is to provide patients with more accurate estimates. So they currently do have estimates, but they want to make it more accurate. So there's a key business requirement, which is for the model to overestimate instead of underestimate. So let's try to think about this. So imagine your bill comes and it's $10,000, and it differs from the predicted cost by $5,000. Okay, it could be that your prediction is $5,000, and now you have to pay $5,000 more. On the other hand, it could be that your prediction is $15,000 and you pay $5,000 less. For each of this, to the machine learning model, the error is the same. So the machine learning model doesn't know which is better. But we know from the business domain that they prefer to overestimate in order to have a better customer experience. Because if you overestimate, the customer walks away happy, right? The patient walks away happy. Of course, this needs to be balanced. We don't want to provide bills that are too high because when patients are looking for procedures, they might be shopping around and they might not, if you provide an estimate that's too high compared to your competitors, they might not even come in for the surgical procedure. But by and large, there's a preference for overestimation. And of course, we have a key constraint, which is that they already have existing estimates. They already have existing UI that their nursing staff, their hospital staff is already using. So trying to build an entire system to change this is really expensive. You need to train all the hospitals, you need to train all the nursing staff, you need to train all the people. It's really, really difficult. So our key constraint is that whatever we build must be plug and play into their existing UI. So that was, so you can see here, we have two key requirements. One is to, of course, clearly we have to be more accurate. Second is to overestimate. And third, we have to do minimal disruption. So given our intent here, let's see how we design a system that meets this problem. Any questions so far? No.
I do have one. So I'm
Yes.
wondering, so why it's not clear what the cost is upfront? Like, why is this a problem in the first place?
This is a good question. So if it's when people come in for surgeries, if it's a very standard surgery, it will be very clear what the cost is upfront. So, but sometimes people come in for surgeries, and we can itemize all the item costs of the all the materials and the doctor's time. But sometimes there might be complications, or all the best we can provide is, people who go through this surgery, they're gonna stay in the hospital for 3 days. But some people might have existing pre-complications, that there might be comorbidities, so they might have to stay longer. A lot of this is difficult to estimate upfront. However, with certain demographic variables like age and gender, it is easier. But you're right, this shouldn't be a problem, but it is.
Okay, I understand. So basically, if there is a complication, then
Yeah.
Extra work is required, and then it increases the cost afterwards.
And they have to stay longer in the hospital, which is quite a significant cost as well.
Understood.
Okay, thank you for that. So now, what is the problem? The problem is that the existing system has very poor accuracy. So it's a very basic system that uses statistical aggregates, and thus it cannot capture the nuances of each individual patient. It just sort of aggregates all the surgical procedures across a certain amount of time, and it doesn't personalize the estimate. And because of this, they found it very expensive to update the models, because it was fully within their control. Every time they update the model, they had to run it through hospital administrators, medical staff, including doctors. So you can imagine the time taken to update this model itself was really expensive, because you're using the time of hospital administrators and medical staff. As a result, this model was updated very infrequently. And when models updated very infrequently, it leads to poor accuracy. So it's a vicious cycle. So how do we try to solve this problem? So I have a slide here that takes us through the high level. Let's have a big picture view of it. First of all, no need to take screenshots, because all these slides will be completely available. So I hope you can see my mouse pointer, but over here, this dotted gray line, this represents the delineation between their environment and our environment. So the hospital environment, the hospital has data on the patient, doctor, and the case, etc. So periodically, they would update extract the data, could be in CSV format or whatever format, and encrypt it via the cipher that we provide. And from their encryption server, they will pass it to us on our decryption server. So on our decryption server, we would again decrypt it, and then we don't do anything. We just put everything in the staging block. That way we have the raw data as how they have provided. Of course, the encryption has to match, and so we know that we have the raw data. Once we have the raw data, so this is usually something in S3 or Azure blob. In this case, we're using Azure. After we have the data, we do very minimal transformation to make sure that it can sit into our relational database. In this case, is Postgres. So essentially taking CSVs, doing minimal preparation, not cleaning anything, putting in the data storage. So this is our raw data store. After that, we go into the data preparation, feature engineering, machine learning, etc. So all these steps, I'll go into greater detail later. So the outcome of this, what we do here is that we train a model. Of course, we do all the necessary data prep and feature engineering. So we train a model, and this gets stored in a ML model storage. So the form of these models, it could be anything. It could be pickle files, it could be PyTorch storage format, or Docker images. I personally prefer to wrap the model in a Docker image, so with the serving code and everything. So that way we know that we can just take the Docker image, run it, and it will be plug and playable. So this model storage, and we'll see why we need to store models later. So after we have the model storage, it goes to a publishing server. So what the publishing server does is that it takes the model And again, it stores it in an artifact storage. So this would be something like Docker registry, Elastic Container Registry. And then it takes that, keeps a copy of that. Oh, so why do we need a publishing server? It could be the case that your ML model storage is not in Docker format, right? Or not in a way that's ready to serve. So the publishing server would do that and put it in a ready to serve format. And then we deploy it. So when we deploy it, each hospital has their own API. So we deploy to the different APIs, and all this is served via API server. There's a thin layer of business logic. For example, maybe hospital administrators want to have a minimum price for certain procedures, or they want certain procedures not to go beyond a certain price, whatever. They can add that. And all this is used by the hospital staff, as well as the general public, if they have access to the website, to call their estimates. So they will enter things like my age, my gender, what my surgical procedure is going to be, what my existing, what my existing conditions are, what procedures I might have done in the past, etc. So they will get estimates here, and again, these estimates get pumped back into the estimate database on their side. So this completes our feedback loop. And over here at the bottom, you can see that this whole thing, we orchestrate, this whole thing, we monitor it via the Elasticsearch, Logstash, and Kibana stack. So all this, we have logs that just get pumped into Logstash and can visualize it with Kibana. Over here on the top, how we orchestrate this is through Airflow. It's pretty standard. Airflow is pretty basic. It's the de facto and it's easy to use. And over here, the publishing server, we use Jenkins. And so you will see that this is built on top of Python. So most of it is Python, PySpark deployment as well. I think our API server might use Node.js, but I forgot the details. And this is done all on Azure. So why it's done on Azure? Because most of the healthcare clients are on Azure, and that's what they're comfortable with. So any questions here?
Yeah, I do have one. So, like, there is this difference between Airflow and Jenkins. So I'm just wondering, why do you need to have two systems? Like, what do you do with Jenkins that you cannot do with Airflow?
That's a good question. That I am not able to answer.
Okay.
So the DevOps, to be honest, this part I'm not. I don't claim this part is not done by me. This part is all done by the DevOps team.
Okay.
So they use the Jenkins for deployment.
Clear. So basically, the tool that the team was comfortable with was Jenkins rather than Airflow.
Yeah, we use Airflow, but I think there's a step in the middle that they felt that they needed to use Jenkins. Yeah. Okay, so moving on. So this is the big picture view, and now I'm going to dive deeper into these steps. More of the focus here, but yeah. This is just a quick view of how this would be organized in code. You can see we are now on version 3. We would have, and this is like the source directory. We have data prep package, feature engineering package, machine learning package, and utility package. And of course, we have our tests, which mimic the exact package. So specifically under machine learning, we have several packages. One is the train package, which trains the model. Next is the validation package, which validates the model before we can serve it. And then there's a serving package. In the serving package, all this does is there's an API, which is essentially just a model class that contains your state. And then there's a package API, which takes our model and package it into the API. That's it. Data validation and ingestion. So you can see that I mentioned that the data comes from the provider environment, and they encrypt it, comes to us, we decrypt it, and we do data validation. So I think this is pretty straightforward, but I think it's useful to chat a bit. So initially, the data was provided via ad hoc SQL queries, and sometimes these SQL queries might not match. So as a result, the schema and field formats might differ. So for example, the data format might switch between UTF-8, Latin ISO, ASCII, and Python. And machines are very sensitive to such formats. It will break. So we have to check the format first. And sometimes we also want to check the columns, right? Whether the columns are the same name or not. So if the column is a missing name and we just continue to ingest the data, we could ingest the data correctly, and we have the entire column full of null values, which is not what we want. Second, we also want to check for duplicate data. So duplicate data is actually very dangerous. Why is this so? So for example, maybe they provide us data week on week, but the data that they're supposed to provide for last week also contains the previous week's data. So in this case, the previous week's data would be duplicated and we might never know. And now this is in our raw data store. And to clean it up from the raw data store is very, very difficult. Once the data is in, unless you allow delete operations, it's going to be very difficult. So we want to check that whatever data that we ingest is no duplicate, no null values. And the last one is volume checks. So for example, maybe we might expect that the periodic volume of the data is about, I don't know, let's say 10 gigabytes. And we know that it should be fairly consistent week on week. However, if the volume of the data on disk is, I don't know, more fluctuates by more than 20%, that is something that we might want to warn ourselves against. For example, you could meet everything, right? Schema, right? Column and everything, but your entire data set is full of empty string and you would still pass. So we also want to check the volume. So after we have done the data validation, and this is on the raw data that is still in our, could be in the CSV format or Parquet format. Only after this is done, then we extract it, load it, and transform it into our raw Postgres relational database. So now this is the raw data store that we are going to be using. From this raw data store, we do some data preparation. So this data preparation is very basic. Nothing too fancy here, but I thought maybe we can talk a bit more about this, some stuff that's specific to healthcare in general. So categoricals, so ICD-9, ICD-10. What is this? So this is the International Classification of Diseases. And right now we are on ICD-11. So we might have different cases where the ICD is different. And to a machine learning model, if you use male, as in M-A-L-E, versus M versus boy, the machine learning model is going to see this all as different, but we know that they are all the same. So we need to normalize this. And of course, standardization in terms of gender and the hospital room types. Numerics. So we want to fill in missing values. So filling in missing values is nothing too special. You can do this by filling in with your mean, your median, or using a special value like -1 to represent missing values. Handling outliers, a very interesting case. So healthcare costs, hospitalization costs is very much right skewed. Is that you're going to have quite a lot of people which have average costs, and there's going to be a long tail of people with outsized hospitalization costs. So are those outliers in our data set? I don't think so, but we want to handle them properly. I think I want to mention here that if any of you, if we are taking the steps of handling outliers in our data, I highly recommend handling outliers in your training data so that your model can at least train properly, but try to leave them in your testing data so that at least your testing data set, the distribution, matches your actual production data set distribution. So that way, you can't say that, hey, in the testing data set, the root mean square error is very low, but why is it so high in production? It's because you remove all the outliers in your testing data set. So it gives you a better sense of how. And of course, we might have other stuff like text, doctor's notes or images, etc. Those have their own handling as well, which I will not go into here. So now that we have patient data, doctor data, case data, etc., whatever, we need to merge across them to generate a single object, a single entity. And the entity here is a case. So a patient can have multiple cases. A doctor will definitely have multiple cases. So we train our model on the cases. And after that, we could do data augmentation. So what does this mean? We might have external data from doctor data from the Singapore Medical Council, SMC. So all this data is available on the website. It tells you how long the doctor has been practicing, what's their specialty, etc. So all this can be useful as well. We also have our own internal features. For example, we've seen a lot of such data, a lot of such diseases, how disease progress across time, and we develop our own disease embeddings that we can merge in. And so this is how we augment the data. Alexia, any questions here?
No.
Okay, cool. Then I'll go into validation. So this part is really, really important. I think this is the most important slide. of the entire deck. I think that in almost all machine learning cases where your model is deployed into production, you should never use a random train test split. So a random train test split, we know this is five-fold cross-validation. We just split into 5 and we shuffle data and we validate accordingly. So the other way is the time-based split, whereby, you know, this is my year 2016. I predict hospital bills for year 2017, 2016 and 2017, predict hospital bills for 2018, 2016 to 2018, predict hospital bills for 2019. I think that most of the time we should only do this. We train only on data from the periods before. And let me share with you an example of how this matters in our specific use case. If we use a cross-validation split like this, we might use, given probability, we will use the future data to predict past data, and the validation results will differ greatly. So what we found is that 19% of our patients had more than one admission. So this is close to 2/5 of the hospital cases that we have. So what this means is that we could take a patient's future admission data when we're doing a train validation split, a future data to predict the past data. And you know, that would never happen in production, right? And also, what we found that in validation, when we use a validation across time, we would have a lot of cases, more than 100 cases, where the specific ICD-10, International Classification of Diseases, so the specific diseases or the specific table of surgical procedure, the specific surgery has never been seen before. So clearly, again, you know that when the model doesn't see anything, it hasn't seen it before, it will not know what kind of embedding or what to use. However, when you do a cross-validation split, you might have that data. So again, it's looking backwards in time. And lastly, we know that medical prices increase over time. So let's say I have 2016, 2017, 2018, and I'm trying to predict 2019, but I also have 2020 data. If I have this, all I need to do is to draw a line between 2018 prices and 2020 prices and just sort of guess what's in the middle. So this is a lot easier than just trying to predict what happens in future. So in our case here, using a time-based validation is very important. So nonetheless, there are some cases where it's okay to use a random split. So for example, I'm just going to take a basic example, product classification. I'm classifying products based on title, based on images. So the distribution of this and their product actual classification doesn't change that much across time. So in this case, it could make sense to use a random train net split. For example, ImageNet. The images and what they are probably won't change across time, right? A dog will still look like a dog. A hamburger will still look like a hamburger. Maybe in 10, 20 years, it might change a lot, but for now, for the next 1 to 2 years, it'd be pretty constant. So that's where a random train test split would work. Feature engineering. So again, we use very, very basic feature engineering. Grouping. So the diseases and the surgical procedures, they have a hierarchy, right? For example, maybe at the top, you have a cough, and then you have a pneumonia or dry cough or wet cough, and another pneumonia, you have different. So one basic way is to just group it to a higher level. Why this is helpful? Because there could be some very rare instances of diseases or surgical procedures that are seldom seen. And by grouping it together, we actually, the model is able to learn it better. And of course, encoding it, it's up to you how you want to do it. You can do one-hot encoding, binary encoding, numerical encoding. I mean, I won't go into too much detail here. Or right now, what most people do is, just create embeddings for these. Numerics. So let's say we have our numbers, we want to normalize and bin them. So one important thing is that, again, hospital data is very much right skewed. So it doesn't have a normal distribution. So one way to fix this is to create statistical transforms. For example, the most standard one that works very well is to use a log transform. You just log all the values and it becomes somewhat of a normal curve. In our data, we have very interesting data on date time. So what this means is that we have time differences such as age, and we have details. So details is a very interesting aspect in our data that we found. For example, imagine someone trying to get an estimate on a Wednesday afternoon. Okay, someone's trying to get an estimate on Wednesday afternoon. And then imagine someone else, the same person, okay, the same person trying to get an estimate on a Saturday night at 2 a.m. Which of these is going to be a more serious case? Clearly, the one that's on Saturday night at 2 a.m. when they come in a hospital and the nurse is there trying to get an estimate. That is clearly a more serious case. So while we may not know the extent, the severity of the case, because this is before the nurse has entered in triaging or the doctor, but one interesting instance we found is that the time of day matters a lot in terms of how serious it is. So that's something to think about. Lastly, we have interactions. So interactions is essentially just cross features. You cross your age and gender features or your age and surgery features, and they become a new feature. So age and gender basically a male and whatever age and surgery. Certain surgeries are, in general, surgeries are not so. The older you are, the less well a surgery is going to go. However, for certain surgeries, this matters more. So if you cross these features, you can also see a lot of things. And of course, conditional probabilities. Essentially, it's just a grouping, and then you calculate a conditional probability or the conditional, or you get aggregate costs, and you use that as a feature as well. Any questions here so far?
Yeah, I'm just wanted to. I think I understood why the time of day is important. Just wanted to double check. So basically, like, if it's not serious, you wouldn't go at night. You would just spend night at home and then show up in the hospital the next day, right?
Exactly. You wouldn't be there at 2, 3 a.m. Usually the cases that are there at 2, 3 a.m. are emergency cases.
Mm-hmm. Okay,
yeah,
makes sense.
Machine learning. All right. So I don't know what the level of the audience is, but when I was preparing this, the level of the audience was pretty basic, and to them, machine learning was a black box. However, machine learning is not a black box. As you and I know, it's actually pretty basic. We have models and objective functions. So over here, we have different models. I'm just going to list the standard ones: k-nearest neighbors, logistic regression, decision trees, neural networks, regression neural networks. And in our case, we're predicting a number. So we have different objective functions like mean squared error, mean absolute error. However, one thing is that the mean absolute error, the second order derivative is not curved. So we might have to use other things like Huber and Fair. Feature selection. Again, you can just use classic feature importance. However, one thing to note here is that classic feature importance doesn't really work correctly. So what do I mean by this? So imagine that you are trying to predict the likelihood of breast cancer in patients, and you only have two features. You have age and you have gender. So let me ask you this, Alexei. What is the first feature that the model was split on in predicting breast cancer?
Gender?
Yes, gender, right? Because everything that is male will not have breast cancer. And then everything that's female has, and then after that, it will split on age multiple times, right? To cut it. From the model's perspective, because it splits on gender only once and splits on age many times, age is a more important feature. If you use regular decision trees, you do dot feature importance, that's what you could get. But we know that gender is actually the more important feature. But the way that classical feature importance is calculated, this does not come out. So we might want to consider permutation feature importance or drop column feature importance. Now, data weightage. This is a very, very interesting topic, at least in our use case. One interesting thing that we tried is to weigh the data by time, because we know that the older the data is, the less relevant it is. So we tried to decay it linearly or exponentially. And of course, we have domain knowledge on how to weigh the data correctly, weigh the data properly. So for example, while working with our clients, the hospital administrators, they told us, that this data is more important, that data is not less important. They told us to exclude certain data, which is wrong, which is completely new to me. I always thought that more data is better, but they actually told us to exclude certain data that was teaching the model the wrong thing. So that's what we do here. And of course, parameter tuning, again, the fairly standard set of tools, random or grid search, or Bayesian optimization. So that's all we use in machine learning. Deploying it. So you can see over here in the middle, we have a train, validate, and deploy loop. So train, validate, deploy, all this part is very much within our control. We can say that when we deploy a model, we know what the validation score is. So this part is pretty straightforward. However, after that, we get feedback, which is the feedback that we get is the future errors between the estimation and the estimate. So once we get the feedback, we can again optimize our model and retrain it. And so you see previously we have this model server. We have a server that stores all our models and all artifacts. So what this means is that, let's say every week or every month, we are training a new model. Let's say we deploy the model, and we can just give a standard deployment. If you pass the validation test, you just go to deploy it. But it could be that there's a model that passes the validation test, but actually it's not what the customer wants. Anecdotally, they might say that this model performs worse, though it has never happened. We want to have the ability to version or rollback. So anytime we say, hey, this model is a bit iffy, can we roll back? Boom, just take the last Docker image, deploy it, that's it. It's 2 minutes of an engineer's time to do that, and no one needs to work over the weekend, no one needs to stay up late, right? This is your insurance policy. Of course, I know that I've made this look very simple, but this is only the steps that I can talk about. There's a lot of complexity behind here that the rest of the team was working on. So this is by no means a one-man show. They had to take care of the infra, how to get our cloud to talk to their cloud, the security, the encryption, the networking, how to get them to be able to call API via an express network so that they get the best. They get the best latency performance, and modeling and monitoring, which I didn't cover. So all this, we try to just hide it away from them, and we provide them an API. So the API, let's just say, for example, it's JSON based. They provide us the demographics of the patient, some information about the case, maybe the surgical procedure, the disease that they have, and maybe what kind of hospital room they're going to stay in, who the doctor is. Different doctors charge different prices, and we try to predict this. So all this is what goes on in our environment, and all this is abstracted to them via in their environment, and they can just plug and play it into their existing UI. So there's a few things that I didn't cover in the previous slides, but I think it's really, really, really important. I think it's really important to take time to learn from the domain experts and users. For example, they may have certain assumptions, they may have certain human intuition about patients coming in, especially if they have multiple conditions or multiple surgical procedures that are not always visible in the data if you're just looking at data. So what we did was I went to each of the hospital, I just sat down with them, seeing while they use the tool. And then sometimes I would see things that are not tracked in the data, and I ask them, why do you do that? Why do you think that way? And based on this, we can create better features, or at least put some safeguards, right? So this is really, really important. And this is the one thing that made our models a lot better, far better than parameter tuning or feature engineering, which is trying to understand the problem and how they're going to use it. Second big takeaway is more data is not equal to more features. So here's a very clear example. We have data from many, many hospitals. So my initial approach was to, just take all the data from all these hospitals and just create a big model, right? You would think that, with a hospital variable, the model should be able to learn all that. However, it doesn't. It doesn't work that way. So different hospitals have different price points. Some hospitals are the 5-star hotels equivalent. Some hospitals are the regular suburb hospitals where they don't charge so much. And different hospitals have different specializations. Some hospitals specialize in enrichment disease, for example, heart attacks, or stent removals, or cosmetic surgery. Some hospitals specialize in the regular accidents like fractures or certain things. So different hospitals work very differently. And by training a single model for each hospital, we found that it works much better. So again, that's an example where more data is not equal to a better model. And lastly, better engineering practices makes everyone's life easier. I hope I've made it clear through this, through the talk of the slide, like having different proper directories, having test cases, having proper versioning, not just code versioning, but model versioning that allows you to roll back, having proper orchestration and logging. It just makes life easier for everyone. Overall outcomes, essentially we reduce error by 50 to 60%. We reduce the amount of underestimation. We improve the query latency. I think this is actually like 40 or 60 milliseconds. Previously, it used to take them 5 seconds because each new query was actually a SQL call. And we allow it to customize it at the hospital level. So previously, their model was a one-size-fits-all for all hospitals, but now because we build it for each hospital, it's better. It performs much better, and each hospital can tweak it according to their desire. Integration of business logic. So we added a tiny business logic layer. So this could be that, hey, they want to fix certain prices, etc. Minimal disruption. So how do you do the cutover? Essentially, hospital staff, people using it, we just go to bed one night and we switch the model. We just switch the API call, and the next day they woke up and that's it. There's no difference. They felt that the accuracy was a bit better. It felt a bit more correct. They saw more variability in the cost, but that's about it. And of course it was faster, but they didn't quite notice it straight away. But there was no retraining required and everything. And this is so a lot of times we talk about models generating profit or saving costs, right? In this case, the way we implemented it saved costs because we didn't have to do expensive training and all that. And a hospital, right? They have to be continuously. It's an essential service. It's an essential service that has to be continuously in production. So it's very difficult to take time out for training. Of course, we reduce costs and increase the frequency of updates. Our system is built for daily updates, and anecdotally, based on customer experience, we know that there were almost zero complaints. As we roll out more tanks of this, as we roll out more versions of this, I would go to the user acceptance testing. I would sit with them to see it. We got a lot of thanks from this, and that is very fulfilling, right? The hospital staff will tell us that, hey, this works so much better. We get so much less complaints. We get so much less questions or pushback from patients who ask for estimates. And we know that this actually helps the hospital staff and the patient experience a lot. So key takeaways, building data products is a team effort. So you saw my overall architecture at the start. I only worked on the data preparation and machine learning stuff, maybe a bit of the model wrapper and deployment, but a lot of it, I had QAs to help, software engineers, DevOps, and a PM. So this is by no means all done by me. We have a team effort. And of course, be humble of the data. Don't assume anything. One big assumption I made was that combining all the data into a bigger data set would work better. But we know from here that this is not the case. So that's one key thing. And lastly, I know this has been said so many times that it's a cliche, but machine learning is really less than 20% of the effort. The methodology, how we frame the problem, how we implement it, how we execute, how we deploy it is far more important, has a far greater impact on the final outcome. That's it. Thank you for listening. I'll be sharing this on my website. Please go there if you like such material on data science and machine learning production, and I'll also be tweeting about such stuff on my Twitter handle, so you can follow me there. Thank you. That's it, and I'm open to any questions.
Yeah, thank you. So I have one question. Like when you mentioned a few slides back about customization, here at institution level. So I was wondering how much work, like let's say you want to onboard a new hospital. I don't know if it was the case, if you actually needed to do that, but let's say if you needed to do that, how much work would it require to onboard a new hospital into your system?
So onboarding a new hospital, technically it's not difficult. So I'm trying to think through how we would do it now. We would provide them, hey, this is the schema that we expect your data to come in. They provide us the data in the right format. We would train the model, and we would validate it, and we would tell them, hey, okay, the accuracy is about this level. If you're okay with it, and then we deploy it. So the code base and the pipelines, everything is exactly the same. The only difference is we take in their data format in their schema, in their data in the same format, and everything is exactly the same. Essentially, you could just take this, if all the hospitals provide the data in the same format, we would just take this and put it through the pipeline, and it would spit out a model deployment object, and we would deploy that.
Okay. Yeah, just wanted to remind that if you want to ask a question through slide, that there is a pinned message in YouTube chat. You can just click on the link and ask a question there. We also had a question in YouTube chat. It was in the very beginning about insurance. Like I think like I don't know how it happens in Singapore, but let's say in Germany, like when you have some sort of when you need to go to the hospital, usually insurance pays, so not a person out of their own pocket. And at what point insurance is involved into this procedure here? Like, are they the main customers here, or people still pay themselves?
I can't quite recall, but I would say that in Singapore, insurance is covered, but it depends on the coverage of the person. So different people have different levels of coverage. For example, one level of coverage is complete coverage, and that is very expensive. Another level of coverage is you have to pay 10% or a maximum of, I don't know, maybe $3,000 of your own pocket before the insurance pays. So I do recall that the hospital staff would take some of these estimates and run them by insurers to sort of get a letter of authorization. I don't think it's a letter of authorization, but a letter of some sort from the insurer that, we are going to cover this up to so much. But I don't think that even if the estimate is wrong, the insurers can decline to pay because it's part of the insurance coverage. So yeah, but I'm afraid I'm not quite familiar with that aspect.
Okay, so insurance is involved. It's not just this is not something you were exposed to.
Yeah. So if insurance is involved, I recall now that there's a very interesting. So we do have insurance of the patient as a variable, and it's pretty interesting how this works. So one thing we found is that patients with higher levels of insurance actually get higher medical bills. So I'm not quite sure what the correlation is. It could be that people with higher levels of insurance are older, therefore their treatments are more expensive. Or it could be that when the doctors see that, hey, you have higher level of insurance, I'm going to give you the first class stuff, and they can make more money as well. I don't know.
Okay. Yeah. Well, I do not have any more questions, but let's wait for 10-20 minutes because there is this delay. So if you want to ask a question, so click on this link that is pinned, ask a question. And if we don't see any questions in 20-30 seconds, then...
No problem. Yeah, I think everyone's tired after 4 days or 4 hours of conferencing, right?
Yes.
Yeah. So it's expected.
I am, yes.
Yeah.
Not everyone probably stayed that long.
Yeah. And as I guess a reminder to everyone who's listening, we have 3 more days of conferences in the next 3 weeks on topics of career, machine learning in production, and processes.
Yes, exactly. So the next one will be about processes. Then it will be about career, and then the last one is about machine learning in production. Exactly.
Yeah.
And all the information is, of course, on our website. And there is a new question. Yeah. Is the patient data anonymized? How is privacy concern addressed?
Yes. So our model doesn't use patient ID. So in that case, it's anonymized. And using patient ID is really a clear case of overfitting. So we don't use that. Nonetheless, things like demographics and gender do make a big difference in the prediction costs. So, yeah.
And the reason you don't use ID, because I assume there are cases when knowing the past history is useful, or not for this particular use case.
That's a good point. There are cases whereby knowing the past history is useful, but we don't use that because we don't. In the first place, I think. So I can tell you for certain that in the first place, when they pass us the data here, the patient ID is hashed. And there's no way for us to track it. And we don't want that. We don't want that data in our system as well. It's a lot more compliance work. So therefore, what we do is we rely on the hospital staff when they enter the data. They sort of have to tell us what were the previous cases they have. That's all that's how we try to get around this.
Okay, makes sense. Thank you. Well, I guess that concludes our talk and the track for today. Thanks a lot for coming, for joining, not coming. So I should stop saying coming, right? Because
Yeah.
it's, well, yeah. Thanks a lot. That was nice, and I really liked your slide with like miscellaneous stuff. Like like these 3 bullet points. I think they're like. I should print and put it on my wall. Yeah, that's
yeah. I think
great stuff.
I think people don't focus on that. Don't focus on it enough. The miscellaneous stuff, but that's what really matters. That what's make a big difference in terms of model performance in production, as in the impact that you have. So I don't know. I hope it's useful for the audience as well.
Yes, for me definitely. Thanks a lot, and thanks to everyone for staying for 4 hours. I know it was difficult. Of course, everything will be like it's on YouTube, but then I'll cut the video and upload each video separately. And then from you, Eugene, I'll need slides.
I have a link for you.
Yeah. Okay. Cool.
Okay.
And then people already know how to find you. Your first name, last name.com, right? And then all the information is there. Thanks a lot for joining, and have a great weekend.
Take care, everyone.